29th Conference of Information and Software Technologies. For the KTU staff presented here, I would like to express my commitment for the organizing this conference and, of course, for the commitment of the university. You know, we are living in a very digital era, I could say, yes, and with very big challenges, not only opportunities, but also challenges. And I think the knowledge you are going to share with your colleagues, the networking, it's very important, not only to you, but also maybe to others who will joining us even online. Reviewing what we have here at Kaunas, I would say that Kaunas University of Technology is one of the hubs here in Lithuania related with ICT. Why I'm telling you this, from my point of view, the human resources we have in here, the infrastructure we have in Kaunas, we could say that we have a unique opportunity to go further, especially with the new trends in ICT. New trends, I'm keeping in mind artificial intelligence, application of artificial intelligence to various spheres of industry, business, and public life. I'm very proud that in the last Horizon 2020 program, the Kaunas University of Technology was the leader in Lithuania by participating by the number of the projects. Totally we had 48 projects. Now, as you know, we are finishing the third year of the Horizon Europe program. And just very good news from this summer that totally we are contracted 24 projects from Horizon Europe. So that means it's not the middle period of Horizon Europe, but we having half of the total projects. From these projects, there are two very important projects and closely related with the topics of this conference, and they are related with artificial intelligence. So again, I'm glad to the researchers of the Faculty of Informatics and also other researchers from our university that we were able to prepare very good proposals. And in Kaunas, we will have two Horizon teaming projects, one with value of 30 million euros, another of 20 million euros. In one, where Kaunas University of Technology is a coordinator. Another project, Kaunas University of Technology is a partner. And the goal in both these projects are to establish the centers of excellence in AI here. The project we are coordinating, we just started recently at the 1st September of this year. And I hope after 2 years, if the conference will be organized here in Kaunas, in the campus, I hope that we could organize this conference in the new premises of AI Center for Sustainable Living and Working. And there will be a good opportunity to see the topics. We are going to develop AI solutions for industry, for healthcare, for energy, and of course for the civil engineering. But when we're talking about AI, it's not only important hardware and software, but also it's very important that we are able to prepare a new generation of researchers who are able to create new AI methods, to apply the AI methods for the solutions. So also it's my message to all of you. Maybe in 1 year there will be calls regarding the PhDs and the postdocs. We are waiting here in the Center of Excellence. So bring that message to your colleagues, or maybe even to you if you are able to participate. So it will be a long-term and sustainable funding for this initiative, and I think it's very important. Another one, when we're talking and looking for the future, I think we understand that any one researcher cannot solve global challenges we're facing. So it's very important that we are collaborating and cooperating our efforts trying to solve these challenges. Why I'm talking about the challenges? the Kaunas University of Technology participating in one of European University Alliances. The alliances is called European Consortium of Innovative Universities, and we're trying to reshape the research, I could say. What does it mean? The idea is, okay, to go to the challenge-based research, innovations, and education. The idea is to involve more and more the society in the providing or generating the ideas. What's important to society? Because as you know, everywhere, especially higher education, feels the pressure from the funding bodies that, okay, we need to show the impact to the society. And even more, the solutions we are providing, we are not necessarily could be accepted by society in this case. So in that case, from the innovation point of view, for us it's very important that from both sides, the researchers who are providing possible solutions, and from our side, the customers, potential customers who could use these solutions, we align their interest from one side and from other side. And finishing my short presentation about the Kaunas University of Technology, I would like to invite you to share knowledge, to have a good networking. Of course, maybe it's also a good opportunity, especially for the PhD students who will be presented today in the conference, to find the researchers who could be later the members of the defense boards in their PhD thesis defense councils. So thank you very much for attending this conference. I wish you a great days here, not only days, but also dinners and maybe other networking events that will be here in Kaunas, and also looking to outside to the weather. Also, I wish you a good weather. Thank you very much and good luck.
Thank you for Vice Rector, and hello and welcome everyone. And we are lucky to be in such beautiful location with so many beautiful places close by. So I hope that it is not the main reason you are here. Yeah, and so the 29th International Conference on Information and Software Technologies, ICIST 2023, is taking place in Kaunas, Lithuania. So we are very happy that despite the difficult geopolitical situation, and as every year we get great interest from scientists from all over the world, and in this event, and that it brings us all together every year. So we are happy that Professor Marcin Wozniak, who is a full professor at the Faculty of Applied Mathematics, Leiden University of Technology, and chief scientist at the Institute of Future Intelligence in the United States, Dr. Charles Shih, accepted our invitations to participate here in this conference as keynote speakers. Thank you. I also want to thank everyone who helped organize this event, including the heads of the university administration, heads of the faculty, including dean, vice deans, the members of the program committee, chairs of the sections, technical staff, and all others who contributed to the conference, but I did not mention. And of course, the participants themselves, scientists and researchers, authors of articles and presentations. So today, after Professor Marcin's keynote speech, we'll have 3 sessions. The first session will be a special session on intelligent systems and software engineering advances, part 1, and as well part 2 the same session, and we will have a special session on intelligent methods for data analysis and computer-aided software engineering. So tomorrow we'll have 2 sessions, so special session on language, technologies, and smart e-learning applications, and special session on artificial intelligence-based IT solutions, so part 1 and part 2. Of course, it is a pity that a lot of foreign colleagues did not have the opportunity to participate here on site. To come to Lithuania. They will join us on a remote way, and I hope that this won't get in the way from gaining new knowledge, getting to know new colleagues, gaining new experience, but also having a good time here in Kaunas in Lithuania. So welcome to the ICIST 2023 conference, and let me introduce keynote speaker, Professor Marcin Wozniak, who is currently a full professor at the Faculty of Applied Mathematics, Silesian University of Technology. So, Marcin, the floor is yours.
Thank you. For a nice welcome and the speeches about the era of internet and the era of artificial intelligence. The things that I want to show today and have a conversation or scientific debate after my talk for the future will be organized for the topic of artificial intelligence and Internet of Things. So the topics that are currently one of the hot topics, both in applications but also in theoretical things. I would like to show and I would like to discuss some research results from my team, from my colleagues that we are doing in our laboratories, and the conversation for today will be divided in small parts, so a little bit like introduction, and then we should talk about smart environments. Smart environments for the today topic I have selected smart home, as we have some nice interesting results from our research. So we will be discussing applications of AI technologies, AI systems like fuzzy systems, heuristics, and neural networks. And then I hope to open a nice discussion for the topics for future cooperation and talks. So just to start, what is connection between Internet of Things and what is the connection between artificial intelligence? If anybody is using internet, so I hope everybody is using internet, so just to type Wikipedia, what is Internet of Things, and it says, it describes that this is just a connection of some objects, yeah, that they are connected somehow via network, and the objects are using some sensors. From the sensors we are having information, and this information is transferred, is processed, is, let's say, recalculated. Something is done with this information, and the knowledge that becomes from this process is giving, distributed, is giving a new chance to share between those appliances of the Internet of Things. Yeah, and we can do something. We can have some expert systems, we can have some recommendation, and several other activities. So for the topic, we can simply say that we need first of all some infrastructure. Yeah, so basically now everything is connected to internet, from the mobile phone, the fridge, actually everything can be connected and the information can be gathered. Then if we have this, actually to do the Internet of Things system, we need to discover the process of information transfer, or the process of communication. So we need to know how the sensors are working and what kind of the protocols are inside, just to transfer the knowledge. And then we simply use it. We simply use it in the systems of artificial intelligence. And as the topic is done for smart homes, we have selected the things, we have selected the areas of interest for our potential research. So it means that we decided to check where and what can we apply in smart homes, smart buildings, because smart home is not only like a home where we live, but also a building. We have factories, we have industry 4.0, 5.0, and several other. So all these can be smart homes, smart buildings. And what kind of things we can use in such appliances? So if we think about the development of such environment, we need to think about several aspects. So first of all, it is like connection, but the connection needs secure aspects. So the security of connection, of information transfer. Then there is kind of also protection of the environment itself, and then this is the part of let's say electrical or network appliances, and the rest is divided to the knowledge or the information that we have from the system. So we can have intelligence, we can have some data systems, we can have another things that are called context awareness, yeah, because in such environments the sensors are getting different information, so it can be image, it can be voice, it can be text, or several other things. So this is like context awareness. And also we want those systems to be self-explained, self-working. We can call it like self-extension, yeah. So this is the part where we can easily connect other technologies to our system. And if we think about areas, what we can do, we can say that there can be some kind of a science inside. And this is mainly the part of the topic that I want to concentrate together. Since the introduction was about artificial intelligence, the most important things, or let's say the basics of artificial intelligence, are like fuzzy systems, are like neural networks, or are like also heuristics. So these are the methods that are doing something with the data. Of course, we can have some other related sciences, which is like graph theory, which is like statistics, or several other. But let's concentrate together on fuzzy systems, neural networks, which is actually altogether called like machine learning, because we can have neural networks, we can have deep neural networks, and several other types of neural networks. So this topic is like machine learning, and then we have heuristics. Yeah, so this will be the science things related to Internet of Things, and we will try to connect. We will try to make some use of the sensors or the things that can be mounted, can be inside smart buildings, smart environments. So about the technology. And if we look at the figure, we can see that there are sensors, there are Bluetooths, there are several platforms, there are also solar panels, there are different appliances for energy, there are different things like robotics, and also there are some data storage. So basically all this will be related to the systems or the project that will be presented in our today meeting. And for those two, what we develop or what we create are some kind of ready solutions, but they should be related to social aspects. So the ready solutions means that we can do some monitoring tools, means that we can have some healthcare tools, some home security, or several different. But for today's talk, I have selected, let's say, two important topics. So One of them will be like a little bit of the healthcare, or maybe other system that is able to help elderly people not to be alone at home. And the second will be connected to ecology in the house, so reduction of energy use in the house by using the systems of artificial intelligence, and it is all giving the social aspect. So it doesn't mean that only the owners of the house are more happy because they pay less for energy, but also that, as I said, our grandfathers have still contact with the children, so they are not alone at home. There is also ecological aspects, which is quite important now, and several others, depending on the appliances we are using. So if we look at the topic, or if we look at the published papers, or if we look at the projects that are currently run, we can see that they are selecting some kind of technologies or some aspect that are being investigated inside. And this shows that mostly Wi-Fi, so the connection without the wire is used in such systems. So this is infrastructure, this is Wi-Fi, and if we can see on this, this is like more than half of the projects, more than half of the papers is connected to hardware, is connected to network, and the rest, if you can see, is connected to some kind of idea, some kind of technology. I'm talking only about Internet of Things, but this is widely understood as the technology of Internet of Things, as I presented in one of the first slides, is about having electronic devices. Yeah, so it is also visible in the results of projects, research papers, and so on, that more than half of the research is done on the electronics and technology. And what we can have inside, what is smart building, smart home? So the system can be oriented on some protocols, some kind of devices, some kind of sensors. If we are talking about energy saving, which will be one of the topics for 2-3 projects that I'm going to talk about, we can do the expert systems that is related to machine learning. Machine learning is, we broadly understand, different types of data processing, which in our case will be neural networks, and then some rule-based systems, or other systems where we have expert from the field that is giving us some suggestions, some ideas. So this will be fuzzy system approach. And otherwise, if we have only, let's say, theoretical or mathematical model that is describing the phenomena inside the house or inside the appliances that we are using, it will be heuristic model that is helping us to solve some kind of optimization problem. And all this together with the electronic infrastructure will help us to make energy management and control for IoT. So this is basically the right part of IoT systems diagram that we have here in the slide. So where we can apply or where we can use it, as I said in the first thing, is smart home, but it's not only smart home, there is also smart building, smart factory, smart cars, smart other means of transport. We are going today to concentrate on, let's say, those two parts here, like home and factory, that we have created real systems that are managing the data and that are keeping the, let's say, safe and good conditions inside to maintain the level of satisfaction from the users. So first of our projects, first of our examples, recently published in Transactions on Industrial Informatics, was to use the neural networks and also connection with rule-based approach to create some kind of a system that is able to maintain good conditions of air conditioning and other related aspects to the users of at home. So we have developed both connection, both the appliances of electronics that are able to help users of the home maintain good conditions inside, and those conditions are related basically to the user itself and the demands of the user. And the steering, the control, the expert system inside here was based on two approaches using neural networks and rule-based systems. So in our flat, we have mounted sensors that were measuring temperature, that were measuring humidity, that were measuring light, and readings from those very simple sensors that we can actually buy in every electronics shop in the world. Was processed by the central unit. We have connected them using Wi-Fi connection. The information from those sensors was very simple, like temperature, humidity, and the light. So it means that somebody is in the room because the light is on or is off. And then what is the temperature, what is the humidity? So it is still confirming that somebody is inside. And then you can program separate conditions for each of the room. So when you are entering the house, the system is recognizing the users, and after it is setting the condition for every of them in a way that they need in the room. So the children have separate conditions, parents and the other users. The only thing for this kind of a system is that you have separate control in each of the rooms or each of the places where you want to put the control. Yeah, because when you have one unit for whole the air conditioning system, then it's hard to do it. But if you have different units of air conditioning, then it is possible to make one control over them. And you are doing this in a way that we can see in this diagram. So basically, we need to get the information. Yeah, so it's like sensing layer of the system. Then we have electronics. So this is kind of a processing with the data, and a service layer. So this is the control management that is pushing the information outside. And how it's working with this combination of different information, because we have information of the numerical vector, we have information of images, and we have to connect it into one expert system. So it means that the system is not the whole, but it's divided into fields of data processing. So different for the images, different for numerical parts of input information. And for each of them, we are using different type of decision support. Yeah? So different type of neural network that is able to work with the data we have inside. And as a result, we have the control sequence, but the control sequence is based on fuzzy rules. So it means that we can get a connection between the information inside and the rules. Like here are showing what kind of control user may want. So these are basically the rules that each of the users is expected. Like when it's the morning, I have temperature like this. When it's the evening, I want temperature like this. Yeah. When there are more of us in the room, I want temperature like this. So these are the rules that each of the user is creating. We put this into the system, and as we can see, that is how the system is working. So we can see expected range of the temperature. We can see the use of electricity regarding the wind outside, regarding the temperature outside, and so on. And as you can see, the system, just using this information inputs related to neural networks and the fuzzy control, is able to maintain the smooth conditions of the environment inside the house. So this was the thing about air conditioning, and further we can expect some system also to optimize the system inside the house to reduce the consumption of energy, because previously we can see that only the system is working to maintain the conditions expected by the user. But let's now go the step further and reduce the energy consumption, so reduce the payment, the bills that we have to do after being happy in our home. And this This work, also recently presented in Transactions on Industrial Informatics, is related to this topic. So we are building a sensor control system that is helping convection in a house. Previously it was a flat. Now we had set up a system in a house, the research house, let's call it like this, of our project. And as you can see, here it was a little bit more complicated because we only had some kind of heating infrastructure inside, but there was no control. So we have developed all the electronics inside with my team. So my colleagues have developed all the things and all the control sensors that you can see here. All the electronics, sensors, valves, and so on are just by our team. And for this kind of them, we have done software, we have done the control system. And I'm not going to talk about all the electronics because let's say this is like a part of the system, yeah. But all those things that you simply see here, yeah, is the diagram of the electronic done by my team. So we have several diagrams on each of the valves in the system. But mainly what we are going to concentrate is how to use artificial intelligence, so the mathematical models, to make the control. So the house is giving energy, yeah. So in the way that the temperature in each floor must be expected different in a summer, different in winter, and the temperature is giving to the water system. So this is something like we have also here in the department or in a house. So it's like water heating system, and we need the appliance like this that is giving the heat to the water, and then the water is transported everywhere. But how to make it optimal? So how to make it the less energy using for the good conditions inside the house. So this is the problem of mathematics, and you have to do some kind of equation that is related to the energy produced and all the factors taken by the system to produce this energy. And kind of part of this system is a set of equations here. Yeah, so we have set of equations based on integrals. The integrals are depending on time because in the time it's all changing. So this is the model that we have to optimize. Optimize means that we have to select, produce, or calculate the condition, the optimum point in which the system is working the best. And how we did this. So the sensors are reading all the information from the infrastructure, like water infrastructure and so on, the sensors that we have seen before. This information is transferred into this set of integrals, and we have data processing module, which here is done by heuristic algorithm. I'm sure that you are all aware of heuristics or mathematical optimization. So we are searching for the optimal point, yeah, optimal point that is solving all this equation. And because, as you see, these equations are quite complex, and we have to recalculate them in a real time. So it's a hard work. So we had to have like a class of mathematicians to solving the problem each second for us. Yeah. Otherwise, we have developed the algorithm doing the calculations. And for this, we have used one of my algorithms, which is called polar bear optimization. I have done this like 5 years ago with my PhD students, and it's using the way that polar bears are searching for food during winter or other times in Arctics. And the special way of the hunting behaviors of polar bears is like solving the mathematical equation. So basically we can say that polar bears were hunting for us to optimize the heating in the house. Yeah. And the process of this algorithm is shown here. So you have input data, and you are moving the points in a data space, the data space of the set of equations given in the 2 slides before. And the points are moved in the space using equations depending on the dimension of the space. Yeah? So basically you can extend the model to any optimization problem, because if you have a 2-3-dimensional space, then you are using this model in 3-dimensional space. If you are having more difficult model, then we can go to further spaces. And finally, the solution is created by the model. And this solution, the optimization, is introduced to our control model. The control model, as you can see, was implemented in the way of using computer and also in the way of using mobile platforms. So it means that the user of the house can sit in a chair, yeah, and do all the control from the computer. But also if he is abroad and just want to set some kind of conditions in the house before coming in, yeah, or just to check how the house is working from holiday or from travel, then he can simply use the mobile phone to check all the conditions, to get all the control, yeah, and make it all work for the house. And this system, the using polar bear optimization, is keeping the temperature in the house with the lowest possible use of energy. The blue line is using our system, the red line is like without our system. So it means that the user is coming home and changing conditions to make it heat or make it, let's say, not so much heat. And those jumps, those changes are most dangerous, because here are all the weak situations of the system, so we can destroy, like the heating. But if we are using our system of the control, the temperature is, let's say, on the same level. Of course, it depends on the things that are happening outside, so the snow, winter, and so on. But mostly the changes are like not so much important. It's 0.2, while here we've got it 10 times bigger. So the system is working quite well. Okay, further, for this kind of systems, we can use ventilation. Ventilation, so it means that we are reducing some chemical factors of the air that we are all using. And this project, this research was put in IEEE Internet of Things journal, so also quite well established venue for the research. And we've been doing also all the electronics and also all the systems inside, because for this part of another research flat, we have developed all electronic systems and all the controls that were necessary to connect and to select the information from the environment, transfer it to our Internet of Things module, which is doing the control. And the control will be done to have the same level of the air quality inside all the systems. So the basics of the control are quite similar. So we have the information, we have the sensor readings transferred further. However, here the control is done only by fuzzy rules. So previously we had some neural networks, then we had some heuristics, and here is only fuzzy rules. We will discover in 2 slides further why only fuzzy rules are necessary. But now let's say about the control. So the control is like a data system. So this is the thing where we are gathering all the information, how the house is working, how the users feel in the house. This is the amount of the air, the temperature, and all the things from inside. And we are developing simple fuzzy rules to make ventilation work. So we have several fans mounted in the house that are trying to transfer air into the house or transfer the air outside the house. And we want to keep the level of CO2 that is, let's say, safe or good for humans. This is most important for us. We can feel it, for example, when we have wrong ventilation and we are working or sitting in a closed space. We are simply getting sleepy after 1-2 hours. Yeah? Because the level of the air, the oxygen inside is not enough, so we are getting sleepy. So we have to make the level of the oxygen higher to make us work more efficient. Yeah, and our system is doing exactly this, just by having fuzzy rules operating on the speed of the ventilation fan inside the house. And if you can see, working with our experts, we have defined the conditions good for health, so bad, very bad, and so on. Good, excellent. So the level of the oxygen inside is bad or good, with levels that we have defined here. And then we have steering or the control sequence for all the ventilation fans inside the house. So they should work faster, they should stop. And this is the complex infrastructure of electronics that I have shown you before. And it shows how it is going on, how is the quality of air controlled using simple fuzzy rules. It is all done in the real time, so we are not waiting for the result. The system is just working in every second. Yeah. Yeah, and the results are showing like what is the level of the CO2 inside when the system is working and when it's switched off. So when the system is working, you can see that we can keep it in the level that is good, safe for us. So let's say recommended by physicians. And if we turn off the system and the ventilation goes wrong, you see the increase of all the CO2 in the oxygen. And basically here we are getting very sleepy. Yeah, so because there's less oxygen to breathe. So this shows how the system works. So the correct air conditions and bad air conditions when the system is turned off. Okay, so this is connected to houses. This is connected to homes, and let us now talk a little bit about introducing IoT to industry. So industry 4.0, 5.0, and so on. We've been working with one of breweries in Poland in a project where they ask us to keep good condition for the beer. So Lithuania has a very good beer production. Yeah, so you know how hard it is to make a good beer. The conditions should be perfect to make the beer. And one of the oldest breweries in Poland came to us and asked if we can help them to produce better beer. So the conditions for production must be related to humidity. The humidity cannot be too high and cannot be too low, because the beer is the process of beer production is harder in those times. So with our colleagues, with my team, we decided what kind of sensors, what kind of electronics are necessary for production. This is the brewery. Yeah, this is under strict control of historical authorities in Poland, so nothing can be changed. You can only touch some part of walls or some part of bricks or so on, because otherwise it's forbidden, because this is a very historical building. So we've been working also under conditions of satisfaction of authorities, which was very, very important for our project. But we done it, yeah, but we have done it. And all the electronics, all the things set here, as you can see, were mounted in the floors of the brewery. So quite big infrastructure, I must say, but also, as you can see, quite simple, because the authorities restricted several things from us. And we use also fuzzy control just to keep the good conditions of humidity, which was not very easy, because for humidity in this building is like wind speed, but also, let's say, the level of the groundwater, what's inside, because the building is placed next to the river. So the water from the river is sinking into the building, and we had to keep good conditions inside such infrastructure. And also good temperature. So because of all the conditions here, we have used the second type of fuzzy logic. Second type of fuzzy logic means that we have control with some uncertainty. Yeah, so normal control is just like the Gaussian curve here, but when you have uncertainty, so it means that you are not sure what would be the change, and this is given in a higher order of the fuzzy control system. So it is called the second type fuzzy control. The rules are a little bit complicated in such kind of a system. That is why we had three sets or three parts of control rules, different for the conditions outside and different for the period of the year that we've been working with, because the different uncertainty is in a winter, in a summer, and so on. And this is the result of our research. So the control for the system given to the brewery. And as a result, we can see how the infrastructure is working. Yeah? So the dotted lines show this expected change. So this is the uncertainty that we have been working with. The range of temperature, the range of humidity, and so on, changing in a time. Yeah. So how the system should keep inside this interval, and the blue line is showing the temperature, is showing the humidity. So basically, we can see that the system is working quite well using simple fuzzy rules. Yeah. And the last aspect of this, the last aspect of the smart environment is to help people, because we have helped houses, we have helped a little bit to the industry, and now we are going to help a little bit us, so the people inside home or inside working site. And the research with my team, we have also published in Transactions on Industrial Informatics. So it shows very simple system using, as you can see, the minimum number of sensors that is predicting if somebody is okay or if somebody is not okay. Not okay means like fallen, sitting, or different position, because something wrong happened. Yeah? So we've been testing what is the minimum number of sensors that is possible to use to predict, for example, if somebody has fallen. This is very important when we have elderly people and they are alone at home. They might fallen on the floor for some reasons, but also we can use it in construction sites or other technical sites where workers may, for example, fall out when they are building a house or something. And we've been testing different number of sensors mounted on the ankles, mounted on the hands, mounted on body parts. And from our research, it is enough that we can use only 2 sensors. However, we've been using the LSTM, which is like long short-term memory neuron. This is quite complicated neural network structure, because it's processing information not only in the infrastructure of the neural network. As you can see, it's quite big neural network here, but also inside each of the units. So it's a lot of information being processed inside, but it is working. And as you can see, the different combination of mounted sensors means the different quality of the system. If we mount all the system, let's say with the production data that we had is like almost sure. Of course, we have this statistical level of changes, but we can say that the system is all sure. And then different combinations, like we put sensors on ankle, belt, chest, ankle, chest, belt, ankle, belt, and so on and so on. So basically we can say that 2 sensors put in a right place on the body, so like a watch or some kind of a bracelet, and the other is giving us the decision at the very, very good level, which is helping to decide. Which is helping to decide if somebody is correct or not. And if we compare the systems to other results, we are also having quite good improvement, which shows that Internet of Things and artificial intelligence can be introduced everywhere. However, we have to think about some conditions. First of all, we cannot hurt any human, or we cannot do anything that is against the will of somebody, or that is against the law, and so on. So construction of such systems is restricted by several things, from biology, history, and human reasons. And then we are restricted from the, let's say, technical fields, so the part of construction, the systems, the electronics that we can use, because they need to be very small, yeah, like for human. And those moisture control systems, that there are several conditions that must be used. Yeah, so I am happy to produce this research, and I hope for good discussion, and I also invite you to give questions. Yeah, so I open discussion now for the future.
Thank you very much for inspiring presentation. So we can share the mic. Well, perhaps your the timing of the projects were slightly different, because I was slightly confused, because you never didn't mention the wind conditions for smart home. It was obviously important for brewery. Well, so that was a funny side. My question is pretty technological. So how do you integrate all these different kinds of sensors into the common Internet of Things? And the second part, you mentioned that you are using some cloud. So how the smart home is controlled if there is no internet connection at that moment?
Okay, so I start from the first question. So the connection of all the sensors is done, simple protocols that are available. So when you are composing such infrastructure, you have to select those Wi-Fi cards and the things that are implemented into our sensors that are working with the same protocol. This is very important. And actually, yeah, we have been facing such difficulties in the project. Yes. Yes. Yes, exactly. Yes, exactly. Yes, exactly. We've been facing this mostly in our first project connected to air conditioning. We started from the control, which was not working very well. And the reason was the different protocol of data transferring. So this is our experience to select carefully the sensors working well with the same protocol. And the second question was about the control and the cloud. When the data is collected, basically you can use any cloud that is working with this transfer protocols. However, when there is no connection from the cloud, only the user from inside the system. There is also always a control panel, yeah, for it. So if you don't have a connection, you have to call somebody from the house to turn it on or turn it off. So it's say this is the basic level of Internet of Things that also our fathers were using several years ago, calling to somebody in the house and asking to turn on or warm it up. Yes, so it's like this.
Thank you very much.
Another? Yeah.
Thank you very much, Marcin, for the nice presentation. Just have a couple of more technical questions regarding the wearable sensors, especially the smartwatches. These are collecting data offline, right? Is there any smartwatch that you have used with online data collection?
Yes, we've been using two different types of smartwatches because of why? We have, let's say, I cannot do a commercial, but we have two general producers of mobile phones. Yeah, one is, let's say, from Asia, and the other is of watches. Different types of watches, because the data is transferred from the sensor, so the watch, to the smartphone, and then further with the connection. It's like this. So smartphone is getting the data from the watch. This is the sensor that we are using.
And one last question regarding, it's related to privacy concerns, like especially for detecting changes of position and walking people and so on.
Yes.
Is it, now there is this new trend of using, instead of, for example, cameras that are very invasive from a privacy point of view,
That's true.
radio-based sensors. Have you had any?
No, we've been working only with those, let's say, standards, most simple sensors, because the idea was like this: just to use the watch or the most simple infrastructure that we can do alone with our colleagues from electronics to develop the system. So only the simplest way.
Nice, thank you.
Okay, more questions?
From upper, yes.
Okay, thank you so much for your nice presentation. So it's a very emerging and hot topic recently, smart homes and smart environment. I am not technical guy who's aware about AI and functionality. I'm working on environmental and their sustainability. So as you mentioned that all smart homes and smart environments, it depends on, rely heavily on electronic devices and sensors.
Yes.
So do you have any plan or methods or projects how you can reuse these energies and this wastage of energies for the sustainable of environment and for this energy? It is very important because we are going to this smart home environment to protect our sustainable environment. So do you have any plan? Because I maybe missed that. Any method how
No,
can
you
we
didn't
reuse it?
miss anything.
Thank you.
We were only concerned on the control level. And these are not wastes of energy, these are changes of the energy that we don't use. So basically it's not like this, that the energy is produced and we don't use it. It's a little bit opposite. We produce only the energy that we need, or we use only the energy that we need. That is why we didn't have to think about the waste of energy or the loss of energy. We are just using the energy that we need. However, we are now working with some kind of control for those renewable sources of energy. So I hope to show some new research soon in this.
Thank you so much. Yeah.
More questions? Okay, I would like to ask one question. Why did you choose kind of, over-complicated testing environment, like, the building involved into UNESCO heritage, the most, oldest building in the Poland? It was the challenge, or it was the kind of fun, or what?
We started with fun because first project was done with my PhD. Now it's a great researcher with Dr. David Połap. So we started with him to work on a control for a flat with air conditioning. And then we wanted, or we had to do some kind of introducing of some our electronics, because it was related to the project that we've been doing. And after the project, the industry was interested. So from fun to industry, it was like this.
Okay, but it was a big challenge.
Yeah, very big challenge, because we didn't have electronic sensors and so on. So we started like computer scientists or mathematicians, and we had to develop the devices. So we invited colleagues from electronic department, and they help us a lot with the
And are you still providing the tests?
Yes, it is working all the time.
Yes,
it is working all the time. It's working.
And you are improving step by step your solution.
Now we are working on this renewable energy, so wind power and so on. So this is going to be the next step to introduce to the system.
Okay, thank you. More questions? Okay, so thank you very much for Marcin.
Thank you so much. Thank you so much for listening. Thank you so much. Thank you so much. I'm very happy to be the guest of this conference, and yeah, for the next years, we are also coming, I hope, with new research and meet you. Thank you so much.
Okay, so thank you, and now we have time, coffee break, and we will meet at the section.
First presenter is not connected. Some presenter outside from the conference. So the topic of the second presentation is investigation of the statistical properties of the CTR mode of the block cipher based on MPF. Please save the presentation. So okay, it's for you. Yes. And I put, I think,
Yes.
it's your presentation,
Yes.
I think.
Yes, yes, yes.
And you have also, it should work to change the...
Yes. So, thank you. Oh, can you do this? I think you can hear me just fine in this room, not as big as room. So, okay, I will talk a bit about cryptography, what we're doing. So, as I am a mathematician, there will be some maths here. So I'll try to explain it as clearly as possible. But since we don't have that much time,
Yes, okay.
hopefully you will understand what our research is about. So in our research, we explored the avalanche effect and the bit independence criterion for the proposed block cipher. And so what I'm going to talk about is I'm going to present what an avalanche effect is. I'm going to talk a bit about the function we are considering in our research. Then I will talk about the group we use, present a bit the counter mode and how we apply it, and then mainly we'll focus on results and conclusions. So an avalanche criterion for the symmetric cipher epsilon, which is so we have a key space, we have an encryption function, and we have a decryption function. So it's defined by encryption function and the decryption function. So we define an avalanche vector in this way. This EI contains all zeros except for 1 in the if position. And so the idea is to take a look how a cipher responds to changing a single bit. And the avalanche criterion is then defined by this formula where we have a Hamming weight for this vector here. The bit independence criterion is whether the bits flip independently of each other. So the idea is to check whether bits of the ciphertext flip independently of each other. And here you see the definition. And ideally, the bit independence criterion of the statistically secure cipher should tend to 0. In practice, it makes sense to consider the average instead of the maximum, so that we can exclude some robust distribution of bits. The function we are using in our research is called a matrix power function. So we have matrices. We have a base matrix Q and power matrices X and Y. We use square M times M matrices such that elements of Q are in some semigroup S, and X and Y are in integers, integer field. So we can define left-sided matrix power function, right-sided matrix power function, and two-sided matrix power function as shown here.
So if S is a commuting semigroup or a group, we have properties left-sided distributivity, right-sided distributivity, and two-sided distributivity, given by those identities. However, if S is non-commuting, then in general these properties fail, and specifically we have this result. The group we use is non-commuting, and the general description of this group is as follows. So we have two generators, A and B, with the following restraints on A and B. So A to this power is an identity, B squared is an identity, and we have the following one. An example is a group M16 defined in the following way. Then the basic actions in our group are defined in the following way, where here we have a floor function, so it rounds to the nearest integer below n divided by 2. An example is presented here for the group M16, and so if we, for example, want to multiply A cubed by BA squared, we get BA. If you want to cube BA cubed, we get BA to the fifth. Our cipher is presented in the slide. So we have a triplet of matrices. This matrix delta, which is a binary matrix, so its entries are either 0 or 1. And we have two matrices X and Y with entries in Z with that index. So here we have an encryption algorithm, and here we have a decryption algorithm. So what this function phi and psi do is they extract powers of generators. This one extracts powers of A, this one extracts powers of B, and then we have the following function. So shifting by kappa bits to the left, for example. And the decryption function will work correctly as long as Y as a permutation matrix modulo 2, which means that modulo 2, this matrix Y contains 1 on 1 is exactly repeated once in every column and every row of the matrix. The following results were proven for our cipher. So the first one is perfect secrecy. So the ciphertext is statistically independent of the plain text. And we have also proven the resistance to passive adversary, which means that encryption function is a weakly secure pseudorandom permutation. Here we have the counter mode. The basic idea of the counter mode is that encryption function E is used for both encrypting and decrypting, which means that the decryption function is never used. And because the decryption function is never used, we can loosen the restrictions on matrix Y, which is what we did. So first we explored the avalanche effect of the original block cipher with a restriction on matrix Y. And what we got were these results. However, these results are obviously not good enough because here we can see that the avalanche effect should always tend to 0.5. And we also compared these results to widely used symmetric ciphers like IIS and triple DES. And here we can see clearly the difference, not in our favor. So the first attempt we did was that we removed the restriction on matrix Y. We have achieved slightly better results, so we can see they're twice better than the previous version. However, again, this is far from ideal. So comparing to these results, we can see that there is work to be done. And what we have proposed is that we imply additional p permutation vectors of size m squared, which defines a way to put these chunks into a matrix M. So say we have a plain text mu, which looks as follows. So here we mean concatenation by this symbol. So if, for example, the permutation vector is this one given here, then the order of those chunks in the matrix are as presented here for 3 by 3 case, for example. And the representation for each block is chosen depending on the sum of the input bits modulo p. So another way, we count how many ones do we have, and then reduce the result modulo p. Doing that, we obtained the following results for p equal to 5. So 5 permutations were enough to achieve this result. So now comparing this result to widely used symmetric ciphers, we can see that our cipher is indeed close to the quality of these ciphers, at least in statistic properties. And after that, we also explored the bit independence criterion for our cipher, for the best case we got. And we obtained these results. So those results are comparable to the values obtained for the widely used symmetric ciphers. So I think, again, these results show that the quality of our encryption is at least comparable to the classic ciphers. We also analyzed the collision analysis, since collisions is one of the reasons why triple DES is now disallowed to be used. So we are interested in how many are there plain text M1 not equal to M2, such that their encryption gives the same result. And here, the set of possible collisions come from this set. So we explored this set for reasonably small values of our parameters, and what we obtained are the following results. So if Y is a permutation matrix, then there are no collisions. If Y is invertible, we have no collisions in the defined set. If Y is invertible, collisions were found. However, their number depends on the key matrices, so we need a bit more exploration here to see exactly what is the pattern. So how does it depend on the keys? And also, since we have to browse through quite a large set, so the search for collisions becomes impossible if the matrix order is greater than or equal to 11. And furthermore, search for collisions must be executed for each block M, which again makes the task more difficult and more time-consuming. So in conclusion, I can say that the average criterion for the original block cipher was not satisfied, and so we performed modifications to fix this issue. And hopefully those modifications were effective. Comparison to widely used ciphers has shown that the statistical properties of our ciphers are relatively close to the widely used ciphers standardized by NIST. And analysis of collisions, well, at least a preliminary analysis of collisions, for our case has shown that this issue can be dealt with, for example, by increasing matrix order, or using invertible matrices. And also, this research was funded by Research Council of Lithuania. So during the activity, students researched during the summer. So my student, Matas Levinskas, and me got these results together with 2 other colleagues.
Thank you.
Thank you.
Thank you very much. Please, any questions for the author of the presentation? Yes, please.
Just one of the first slides, you mentioned that you were, we were going to look what happens if one bit is inverted, right?
Well, yes.
And that means possible attack or noise or?
Yes, so if the avalanche effect is very low, then statistically you can observe what is happening and determine patterns and so on, so can extract some information.
Okay, nice. Thank you.
Yes, it's okay. Any other questions, please? No, thank you very much for your presentation. It is a certificate for you.
Thank you.
Thank you once again. The next presentation, online PID tuning of a 3DoF robotic arm using meta-heuristic optimization algorithm, a comparative analysis.
Thank you very
Please
much. I'll select the
Yes,
slides.
okay, it's a moment. It should be okay.
Yeah, nice. Yeah, so this is a collaboration between the University of Technology and the University of Agder. I am Filippo Sanfilippo. I am responsible for the group of biomechatronic and collaborative robotics research group. And this is just a brief overview of our research focus. I'll try to be short. So basically we work with different kinds of robots, and in this figure here we have categorized them into 3 main layers. The core layer is what we call carriers. So these are robots with different topologies, robots with legs, robots without legs, robots with tracks, robots that are flying, or robots that go on water environments. And these for us are just carriers. We can equip them with sensors and we can use them for different applications. On top we have what we call normally add-on layers. So this is what we can equip the robots with. So for example, we can have grippers, we can have arms or other sensors. But what we really care the most in my research is this layer here. Because we are not building robots just for the sake of building robots, but we want robots to collaborate with humans. So the human-machine interface is what we care the most. So, and here we can see some examples of how humans and robots can interact with each other. So for example, we have brain-machine interfaces that are becoming more popular, some hand gesture interfaces. And these first examples, this one and this one, are used for humans to send commands to the machines. But what if we can close the loop? What if we can get feedback from the machines back to the humans? Here we have an example where we do this. We have designed some devices that can give force feedback to humans. So if I am grasping this object with the robotic arm, I can transfer this force to the human that is still operating that robot. So just to give you an overview. And this is some of our PhD students working on these topics. So today we are going to have this short agenda. First I will introduce the idea behind this research paper, then the methodology will be discussed, then some results and some conclusions will be given. So I know that not each of us is coming from different fields, so I'll try to use simple words and try to be more interactive. So here we are trying to use a meta-heuristic like the ones that Marcin was talking about during the opening. So meta-heuristics are shortcuts. So to solve a problem that is normally complex, and we try to get inspiration from nature. For example, the polar bear algorithm. Here we are talking about an algorithm that is inspired by war strategies. We are in times where war is maybe not the best topic to talk about, but we are scientists. We take inspiration from everyday or existing natural systems or other systems. So we want to use this meta-heuristic or shortcut to solve a common problem in robotics, which is the control of a robotic arm. So basically, when we want to use a robotic arm to make a manipulation task, like lifting this object, I need to set the joints of my arm, right, to a specific angles so that I can reach the target. So this will work if our world will be ideal, but unfortunately our world is not ideal. So we have different problems like energy dissipation, friction, imperfection in the mechanical design. So this means that even if I set my joints to a specific position, most probably I will not reach the target. There will be an error, right? So normally, traditionally, in robotics, we use, since many years, 20 plus years, since the beginning of robotics, we use PID controllers. So proportional derivative integral controllers that are really the basic controllers for robotics. So using PID controllers, we can actually minimize the error iteration after iteration, so that with the robot I can really reach the target, or at least I can minimize my position error. The only challenge is that tuning a PID controller in real life is not simple. So this can be done traditionally with different methods like trial and errors or some more advanced methods, but the challenge becomes bigger when we have robots with, like this one, or even more complex robots with more than 3 degrees of freedom. So then we have a bigger problem. That's where we think that our proposed method can help. And our proposed method, so it's meant to tune a proportional integral derivative controller using a meta-heuristic, which is called war strategy optimization. So we propose basically a hybrid control algorithm that combines the word strategy optimization algorithm with the PID controller to tune the key parameters of the controller. And here, just a small reminder to ourselves, like we can have several meta-heuristic algorithms. Some of them are single agent, like I believe the polar bear algorithm. The one we are presenting today is a multi-agent algorithm. So it's basically, as you can see here, the idea is we have several agents that are exploring the search space in a multi-dimensional space, and iteration after iteration we try to reach our target. So and there are several ways to do this. Today we look at one algorithm that is inspired to war strategies. Some of the challenges when we use such algorithms that are heuristics or meta-heuristics is that in an ideal case we might have only a single minimum or maximum in our search space. But in real cases, unfortunately we find ourselves in this situation where we have multiple maxima in our search space. So the risk is that we get stuck in a point that is not optimal. So with this meta-heuristic, we try to be creative and try to avoid to get stuck in a maximum or minimum that is not what we want. We try to find the optimal one. So how does our proposed algorithm works? As in war, we have an army, and the army is under the command of a commander, and then there is a king. So at each iteration, the commander is leading the army, and the king instead as a legacy is the one that, so let's say that each iteration is a battle, right? The war is longer than a single battle. So the commander can change battle after battle, but the king is normally staying for a longer time. So these two key elements are the ones that are leading the army and the other agents. And at each iteration, we are assessing the fitness of all the soldiers. So each soldier has the same chance to become a commander based on how strong, how fit is the soldier itself. And basically by leading the army towards our search space, we try to find the local minimum or maximum, the optimal maximum or minimum, the global one. So here we have a flowchart with how the meta-heuristic is integrated with the tuning of the PID. So basically the first step, we calculate the cost function value using our model, which is implemented in Simulink. And then we run the war strategy optimization algorithm, and we get the values of our parameters for the PID, which are 3 parameters. The K parameter, which is the proportional gain, the P parameter, the D parameter, which is the derivative term, and the integral term, which is I here, or yes. So KP, KI, and KD. So then we use these parameters and we run one control iteration with our robotic arm. So that means that basically we move the robot to the target position and we assess the error. So are we getting to the target position or we are still far? If we are still here, it means that there is an error in the Cartesian space, X, Y, Z, and the roll pitch IO for the end effector. So basically, we run this control and we measure we take the feedback, we measure the error, and we send it back here. So here we are assessing the error, which is the difference between the target position or desired position and the actual position. So that error is then fed again into the loop for the next iteration. And we have considered two existing or alternative meta-heuristics to compare our proposed method with. And here, in particular, we are considering particle swarm optimization and gray wolf optimization, which are well known in the field. And these are the values that we have used for implementing these competitive algorithms. Here you can see the simulation environment. These are taken from Simulink. We have our, basically it's a block-based programming environment. We have our signal generator, which is the one that is generating the signal, like for example, for the end effector to follow. Then we have the model of our manipulator with the implemented PID controller. And then here we have a set of cost functions that we consider, particularly the error in the Cartesian space. And here we have some way to measure our errors. So here is just a short video. Please click on it. So this is the environment. So as you can see, iteration after iteration, we try to reach a desired position, which is more or less here. We go there and we assess the error. If the error is normally, at least at the beginning, very big, so iteration after iteration, we try to minimize that error. And we tune the PID with the parameters that are spit out from the war strategy optimization algorithm. And then iteration after iteration, we can minimize the error. So here we can see the results. Basically, this is a comparison with our algorithm, WSO, against the particle swarm optimization and the gray wolf optimization. For the 3 joints, we have a robotic arm with 3 degrees of freedom. And so this is in the joint space, a comparison in the joint space. And as you can see, WSO is performing very well compared to PSO and WSO in this specific case, because the error is much lower. These are the gains that are extracted from the 3 different techniques that we are analyzing. So for each joint, we have the proportional, integral, and derivative term. And here is the same results, but shown from in a diagram perspective, iteration after iteration. So the black line is the proposed method, WSO. Red is gray wolf, and blue is particle swarm optimization for the 3 joints. So as you can see, after some time, after a number of iterations, the black line goes below the 2 competing algorithms. So that means that we are getting better performances over a number of epochs. And here is some more results related to how good is the response of the controller to a step input. So that means how fast the algorithm is converging to the desired position. So again, here we have blue is red is the proposed algorithm, green is gray wolf, and purple is particle swarm optimization. The dashed line is the set point, so it's our step input. So that means that all the 3 competing algorithms are converging, but the red line is faster and relatively more smooth, So there are no spikes. So that means that our end effector is not vibrating or oscillating while reaching the target position. So to conclude, in this article we have presented meta-heuristic-based algorithm that we call war strategy optimization, and we have used this heuristic to tune the controller, the PID controller for a robotic arm. And we have compared it against two standard methods, particle swarm optimization and gray wolf optimization. And the simulation results show that the proposed method performs better in terms of error in the Cartesian space and the joint space, and also in terms of response to the step input. So, of course, this is just one possible application of a heuristic based on machine learning. Such an algorithm could be used also for other applications, for example, for other kind of robots. For robots with legs also need to have PID controllers that need to be tuned. Or, for example, during the coffee break, we were talking about humanoid robots made by Boston Dynamics that we all have seen. They can do parkour, they can jump around, and so on. So, and this kind of robots today have reached this level of autonomy because of this combination between traditional control algorithms like PID controllers with more advanced AI-based algorithms that are built on top. So we have different layers of intelligence. But the bottom layer, the low level, that is the one in contact with sensors and motors, it is still based on traditional control algorithms like PID controllers. And with this, I think I would like to conclude my presentation. I'll be happy to answer your questions.
Thank you very much for your presentation. Please, any questions for the presenter?
I have a question.
Please.
Please.
When you compare PSO and WSO, usually a meta-heuristic, if you run multiple times, the result may be different. Is your result based on statistical average of multiple runs, or is just a one run, single run?
We have used different cost functions. Yes, I'll show you. So one of the main factor in the cost function that we have considered is called integrated time error absolute. And it's basically a measure of the performance of the system in terms of the tracking error and the control effort. It's a combination. So how precise is our end effector to reach the target position, but also in terms of control effort. So for example, you can say energy efficiency, right? So it's a combination of this. It's just one possible cost function that you can consider. So I'm not saying that in general WSO performs better than PSO or GWO. In this specific case, it performs better. Yeah. And again, I don't think there is an algorithm that beats everyone else, right? It just, in this case, within your set of hypotheses, it works better. Yeah.
Thank you.
And
I have a question. So, because in heuristics or all the other algorithms that are working on some kind of a population, there is equilibrium state, which means that there is optimal number of the agents cooperating in the system. So, have you done any measures or have you done any research? What would be the optimal equilibrium state of the agents in your system?
Yeah, this is an interesting question, and we have done some preliminary assessment. So, for example, here we have a robotic arm with 3 joints, right? A good question is how can this scale if we add one more degrees of freedom to the robot, another link, right? And Does it scale linearly? Probably not. We need many more agents, especially if we increase the number of degrees of freedom. So for example, we have another robot, it's a snake robot, which has 10 links. It's many more degrees of freedom, right? And we have done some preliminary tests there, and we need many more agents. Yeah, so it's a good question. I don't have an answer, but for sure it's interesting to look how does this scale. Yeah.
Okay. Thank you.
Thank you very much. Any more questions? No, thank you very much for your very interesting. The next presentation is remote, and I don't know how it works. In fact, the topic of presentation is multivariant Bitcoin price prediction based on tuned bidirectional long short-time memory network and enhances reptile search algorithm.
Should be able to hear us. Try to greet him.
I don't know.
Say hello to the presenter with a microphone.
Yes.
Hello.
Hello. You can start the presentation.
Yes, very well, thank you. Just 1 second. Okay, so do you see my presentation? Is everything okay?
We see the presenter mode.
Okay, so hello everybody. Greetings from Belgrade at the beginning. So I will present this paper, multivariate Bitcoin price prediction, where we used the bidirectional long short-term memory network tuned by the enhanced reptile search algorithm. So,
Sorry, can you hear us?
Yes, can you hear me?
I think we have your other screen currently showing.
Sorry, just 1 second. Let me maybe unplug the second one so we will have no issues.
It's correctly now.
Let me share it again, sorry for that.
If it works correctly.
Is it okay now?
Should be okay. Oh no, again, we have your presenter screen.
If you go to display settings.
Okay, so I then no need to present it like this. I'm not sure what's going on. Do you see it now?
It's on my computer here.
Yeah, we see it.
Okay, so can I start now?
Yes.
Okay, so what we dealt with in our paper is the problem of the cryptocurrencies and price prediction. As you might be aware that a lot of people are interested, of course, in the topic, first of all, as appropriate forecasts of the future trends of cryptocurrencies can be very beneficial for some decision making in stock markets, in economy, and so on. However, the biggest problem with the cryptocurrencies is very high volatility of the price and the fluctuations that can happen, and researchers, together with the investors, really try to understand these factors that are actually causing it. So what we did in this paper, we did the forecasting of the closing prices of Bitcoin, Ethereum, and the daily volume of Bitcoin-related tweets. We also examined that in order to try to predict the values as good as possible. And we used the bidirectional long short-term memory, or LSTM. First of all, why we used that? This is a recurrent neural network, a type of recurrent neural networks, and these kind of networks are typically very good for forecasting the time series data, and Bitcoin price is a time series data. However, as in every machine learning problem, the biggest issue is, of course, to select the appropriate values of hyperparameters of the network. So for that particular case, we used the metaheuristic swarm intelligence algorithm, reptile search algorithm, which is one of the novel algorithms, which we modified. So we didn't use it in the original form. We tried to enhance it to try to get even better results. So why we did select metaheuristic algorithm? Because they are known as very, very powerful optimizers, and they have been frequently used in the field to tune different machine learning approaches with quite a big of success. I'm also the part of the team. We are typically using metaheuristics algorithms to tune a variety of machine learning models, and it can really be beneficial. We tested it in a variety of domains, starting from medicine, then power load predictions, then also magnetic resonance images, and so on. So we had some experience with that, and we expected that we will get some pretty good behavior here as well. So we used this BLSTM based on our previous experience that it behaves quite well with the time series data. And as I said, we tuned it with the modified reptile search algorithm. We devised that algorithm to try to avoid the known limitations of the basic version of the algorithm. So as it is the case with every metaheuristic algorithm, every algorithm has some flaws, and they are pretty much well known. And then the solution is either to try to introduce some modifications or to try to hybridize that algorithm with another one to try to cancel out the drawbacks of both and get a better algorithm which can behave properly in this particular scenario. And according to the no free lunch theorem, the problem with the optimization is that there is no, let's say, a general solution to all problems. So you cannot say that one algorithm will be used to solve all optimization problems. And this is the optimization problem, because we try to minimize, of course, the error of predictions of the LSTM network. So there is no universal solution. Pretty much in every case, you need to try several algorithms, and we see which one on this particular problem with this particular network, with this particular data set provides appropriate results. And then we decide, when we see which one is behaving promisingly, we try to even tune it even better by introducing some modifications. I will refer to this in a few moments. So again, BLSTM, as I said, is known to behave very well with the time series predictions. So there were some research in the past by other researchers as well, where they find out that the BLSTM network and recurrent neural networks in general have really promising performance when we forecast some time series data. What we did, so we use it to try to predict the future price movements and fluctuations based on the past data. So the recurrent neural networks typically also include previous data in the calculations, so that's why they are perfect for time series. And as I said, swarm intelligence metaheuristics have already proven to be very good optimizers. So not just in the area of time series, but also in other domains where the optimization is required, such as different problems in viral sensor networks, such as lifetime maximization or localization problem, then cloud computing optimization and tasks scheduling, also a variety of applications, successful applications during the COVID-19 pandemic. So what we actually try to do is to try to combine these two approaches. So BLSTM tuned by the swarm intelligence, and as we have seen from the empirical studies, not just by us, but as I said, with other authors, we have seen that this kind of approach can have really promising results when we deal with the time series, so with the predictions of the time series. So a few words about the algorithm. As I said, how we choose the algorithm. Well, we did first some empirical trials with several algorithms, and the reptile search algorithm in its basic form had the most promising results, so that's why we selected it for further improvements. The reptile search algorithm actually is mimicking the hunting procedure of crocodiles, which first encircle the prey and then they perform the hunt. Hunt is actually very highly coordinated movement of several individuals. These two phases actually correspond to the exploitation and exploration phases of the algorithm itself. So each meta-heuristic algorithm actually has a goal first to explore the search space, and then when it finds the promising areas of the search space, to narrow down the search to try to find the optimal values. So as I said, each meta-heuristic algorithm has some known problems, and it was shown by multiple researchers, and we also confirmed it with testing on the benchmark functions that the reptile search algorithm is very well in exploring. However, it can lack some power when it needs to exploit the search space in the later rounds of later iterations during the execution, when the actual focusing down and narrowing down to the optimal solutions should happen. So what we did, we hybridized it with the Firefly algorithm, another meta-heuristic algorithm, which is on the opposite known for a very powerful exploitation capabilities. So it is exactly strong where reptile search is lacking some power. So we try to combine those two approaches. So the algorithm actually performs by starting with the reptile search, and after some rounds, it starts to alternate between the reptile search algorithm and the Firefly algorithm search equations. So this is the basic pseudocode of the algorithm. I will not go into details, so details are of course in the paper. However, just to explain the main logic, so we have this VS parameter. This is the threshold where we will start to alternate between two algorithms. So before we reach VS number of iterations, we perform reptile search. And then when it is time to try to focus down and exploit the promising space of the search, we start to alternate between the two. So each solution, so in this algorithm is population based, it has a population of individuals. So each individual in the population, after some rounds, when this parameter and threshold has been fulfilled, will generate a random number. And if this random number is greater than another parameter which we introduced to the algorithm, we will perform either Firefly search or reptile search algorithm. Again, these values of VS and SM parameters were determined empirically. Again, we also explained that in the paper. So this is the basic logic of the algorithm itself, how it behaves. So next, to try to briefly introduce the experiments. So as I said, we used this approach to try to establish the appropriate set of parameters of the BLSTM network for the particular problem of Bitcoin price predictions. We used the data set, which included Bitcoin close prices, tweets, and Ethereum close prices from the time period of January the 1st, 2020 to August 31st, 2022. And this is the data set visualized. We split it to standard split in machine learning when we try to predict the time series to 70%, 10%, and 20% split rule, 70% for training, 10% for validation, and 20% for testing. So this is actually the part on which we are testing, which we try to predict based on this previous data on which we train and validate the model. And we also perform the comparative analysis. So we compared the results against other meta-heuristic algorithms which were used for the same task to tune the BLSTM network, so to find the optimal hyperparameters of the network. So we compare it to the original Reptile search algorithm, but also to Firefly algorithm, because we use it in the hybridization, against the particle swarm optimization, which is one of the most well-known algorithms, and against chimp optimization algorithm, which is one of the newest algorithms available. So we evaluated the outcomes by traditional machine learning metrics, such as mean square error, root mean square error, R squared, and so on. We used mean square error as the objective function which we want to minimize. So the hyperparameters which we used and which we tried to tune were the learning rate of the network, the count of training epochs, the dropout rate, the hidden layer, and the count of cell inside each of the hidden layers. So the number of hidden layers could be either 1 or 2. Here are also the boundaries of each parameter where we performed the search. And each meta-heuristic algorithm was run and executed in 8 independent iterations. Each of those were using population of 5 individuals. 8 rounds, 8 rounds in each execution, 5 individuals in population, and 30 independent runs. Why we selected 30 independent runs? Well, meta-heuristic algorithms are also volatile, and they have stochastic nature, so it can happen because they are stochastic by nature, that in some runs you get better values, in some runs you get worse values. So we typically analyze best, worst, mean, average results of each meta-heuristic. And this was the setup for all meta-heuristic algorithms, and these are the results of the fitness function. Again, it was the mean squared error. So you can see that we provide the values for best, worst, mean, and median, and also standard deviation and variance. So in bold, you have the best results. So you can see that the algorithm which we proposed achieved the best overall result in the individual run, but also the mean value, the best mean value among all other algorithms. However, you also can see that Firefly achieved decent results, so it achieved the best worst result, and also it was the most stable, which we see from the standard deviation variance, which were the smallest. So it is capable of providing the consistent results, so it doesn't oscillate too much. However, the best score overall was achieved by this proposed algorithm. And we performed the 3 steps ahead predictions. Again, you can see that for 1 step ahead, the proposed algorithm obtained the best scores, also for 2 steps ahead. But for example, for 3 steps ahead, simple Reptile search algorithm achieved the best scores. This is perfectly normal and expected behavior exactly because of the stochastic nature of metaheuristics algorithms and no free lunch theorem, as I said, which states that there is no individual solution, so you can have these sort of results. However, on overall, the proposed algorithm achieved the best results in terms of R-squared, mean square error, and root mean square error. So we also provided here, so these are the predictions by the proposed algorithm. So you can see that that was the last part of data set which we use for testing, and you can see that it follows quite closely the real curve that happened in that period. Also here we provided as it is common for metaheuristic algorithms, it is common to provide the convergence graphs so that we can see how the algorithm converges in the best run. And also the last graph here shows the diversity of the population during the last round of execution of the best run of each algorithm. Again, it can show how diverse the solutions actually are. And typically it's a good thing to have them as close as possible to the best solution. And you see that proposed algorithm is quite well performing there. The best population in the best run of execution had the Firefly algorithm, for example, but we hybridize it with that and we try to exploit the best from both Reptile search algorithm and Firefly. And finally, this is the actual set of hyperparameters for this particular network as it was determined by each algorithm. So these were the networks that actually achieved the results from the previous slide. So this for the hybridized Reptile search algorithm, this is the number of neurons in the first layer, this is the number of neurons in second layer. This was set as the learning rate with 375 epochs and with the dropout rate of this value. Finally, to conclude, so what we did, to try to summarize briefly what we did, so we proposed this BLSTM model for the predictions of the Bitcoin price, which is a time serial data. And we used the hybrid Reptile search algorithm that we proposed for the purpose of this paper. We compared the results to other powerful metaheuristic algorithms that were employed in the exactly same scenario as our proposed algorithm. As you could see from the results, so the overall results show that the proposed model, which is the BLSTM tuned by hybridized Reptile search algorithm, performed the best for overall, but also for one-step and two-step ahead predictions, which means that it is quite suitable to perform time series predictions of this particular type, so the cryptocurrencies. So what would be our future work? Well, first of all, we should evaluate it against additional real-world data sets. However, the limitation also of this work is, well, it is probably that you can get even better results because, of course, for the purpose of this conference, we didn't have enough time and resources to test all recurrent neural network types. So what should be done is to test other types of recurrent neural networks, but also to try to test other metaheuristic algorithms, also to play around with them, try to modify them, hybridize them. But as you can assume, this is quite a big task. And as I said, we used just 8 iterations in each run and just the population of 5 because these calculations are quite expensive computationally. So for the limitations that would be, and in the future work, I think it is clear. So we will test this on additional data sets and also test other models and other meta-heuristics algorithms. That's it. Do you have any questions? I tried to be as brief as possible. I hope that I fit the schedule.
What is the window? What is your window for the prediction? Is it 1 day or?
Sorry, I cannot hear you.
Maybe you can hear on this.
Can you hear me now?
Yes, yes.
Thank you for your interesting presentation. I just wanted to ask you, what is the window? The time window?
1 day closing price.
1 day. It's a closing price.
Yes.
Yeah. Okay, thank you.
Any more question, please? No? Thank you very much for your presentation.
Thank you. Bye-bye, everybody.
The next presentation is Android malware detection using artificial intelligence. Can we start? So please start the presentation.
Hello, can you hear us?
Let me share my screen. Yes, I want to start my presentation. And my name is Rebecca. I'm a student at Université de Moncton here in Canada. I wrote the paper with my teacher, Fadwa Kenu, and the title of the paper is Android Malware Detection Using Artificial Intelligence. One minute. I will start with the summary of the paper. In the summary, we have introduction, we have the data sets, the proposed method, discussion and limitation of the system, our contribution, and then we will conclude the work. We will start with the introduction. In 2023, this year, there is an Android malware called Hook, which is a banking Trojan. It attacks a US government agency and compromises sensitive files and disrupts its operations. And this Android malware also could access some device remotely and steal banking information from about 4, 6, 7 applications. And in the first quarter of the same year, 2023, we have another case of new cryptojacking attacks. They were registered and target cell phones to mine cryptocurrencies. What is a malware? We all know that a malware is just a piece of code which is written to perform some action, like to attack a system, to attack the vulnerability of the system, to cause damage, to steal money, and so on. And there are many types of malware. Here are some examples. For example, a ransomware. A ransomware is a malware which is written, which targets devices and will encrypt file and take the control of the entire device, the entire device, and lock the screen, and then ask for some money. And we have worm, adware, and so on. And we malware detection evasion techniques. So the malware also use they use some technique to just to evade the detection technique, like they use polymorphism, file encryption, code obfuscation. They are technique just to evade like antivirus environment. In malware detection, we have analysis strategies. We have 3 analysis strategies, like static analysis, dynamic, and hybrid analysis. In the static analysis, it allows to extract features without running the code. And in the dynamic analysis, we have to put the code in a secure environment and to run it to capture the behavior of the malware. In the hybrid analysis, we have, it's mixing the static and the dynamic analysis. Malware detection using machine learning. We have like a lot of machine learning algorithms which have been used to detect malware, supervised, non-supervised, and so on. So why do we need different type of malware analysis tools and techniques to detect malware? So why? It's because malware is a threat to our security, and malware uses vulnerability found on a system. It can use it to steal our money, to disclose our like privacy, and so on. So we need to take an action, like to protect our system using these techniques. That's why we developed a new method to fight malware using extra tree, the smart algorithm, and cross-validation. So this is the data set that we used. It's the SIG Maldroid 2020, which contains this match of symbols, and it contains five classes. So we did some pre-processing and fed the data set into machine learning and got the result. And next, so in the first step, we train some machine learning algorithm, and then we got the result. And then the next step, we use the cross-validation with the same machine learning algorithm, and then got the some results. In the next step, we use the smart algorithm because we have a problem here. There is an imbalance in the different classes. So we use the smart algorithm, which augment the data set and balance it. And we then train with the same data, with the same machine learning algorithm, and we got the result. And then we also use with the smart algorithm, we use bagging the ensemble learning method. We use the bagging method with the same algorithm, and we got some results. We also try to use feature selection, select from model. We train it and we get results. And here are the results we get in these tables. First of all, the results of machine learning algorithm only with the imbalanced data set. And as we can see, the extra tree is at the first position, followed by random forest and the remaining. And when we applied SMART with the ML algorithm, we can see that the result has increased. The result have increased in all the algorithm. And then next, we apply the ML algorithm with smart and cross-validation. And with cross-validation, we can also see that the results have increased compared to the previous results. Now we have like 96.7 for extra tree, and followed by random forest and the remaining result. And next we have ML algorithm with smart and select from model. Here we have the extra tree which has performed, which is at the first position. And next, we have machine learning algorithm with smart and bagging. We also used bagging algorithm. And these are the results. At the first position, we have extra tree, and followed by random forest. So we can see that we got the best result with extra tree, smart algorithm, cross-validation. We got 96.7. This is the discussion part. So we made a table of comparison to compare different works. So we compared the works based on the analysis technique, the method of machine learning used, or feature selection, the type of features, and the evaluation metric is accuracy. So from the table, we can see that this work using static analysis and voting classifier, and these features perform well. Yeah, they got the highest result. And here is our methods. We use static features, we use extra tree, and with this number of features, 139 features, and we also got good result, 96.7. The next part is the discussion. So our hypothesis was how we could develop a method which could detect malware efficiently. So we got the best result in our experiment with extra tree, smooth, and cross-validation. And we know that extra tree is an ensemble method which uses a randomized decision tree to improve the results, and it also reduces the variance and the bias of the model. Smooth algorithm, the smooth algorithm augments and balances the data set, and it prevents also the bias toward one class. And the cross-validation just gives us like an idea on how the model could perform on different folds. The limitation of our system, because we use static analysis features, so there is some limitation because with the static analysis, the extraction of features is done when the features are not run. So without running the feature, so in case of sophisticated malware, our methods will not be able to capture. And with the dynamic analysis feature, it will allow the model to capture the sophisticated malware. And so for the future work, we are just planning to improve the model by using dynamic analysis and to incorporate the dynamic analysis. The next point is our contribution. First of all, we proposed a method. We did some experiments. We used the Sigma Droid 2020 dataset. We use it with extra tree and cross-validation with smooth. And then we explore also the efficacy of extra tree and select from model feature selection. And next, we experiment the same dataset on bagging and machine learning algorithm. Next, we also give the details on the previous papers that had used the same dataset. So to conclude this presentation, so we reached our goal because we were able to develop a method which performed well. So we explore also bagging and selection model, feature selection, and in the future we will use dynamic analysis to improve our model. Thank you.
No questions? Thank you very much for the presentation. I have a question. It is possible the first presentation is somebody connected or not? The first presentation? No. So thank you very much for participating in today's session. The session is closed. Thank you very much.
I would like to thank you for head of this session, for the chair of the session, Professor Zbigniew Marszalek. So thank you very much for your help and support. And this is our small souvenir.
Thank you. Thank you
Thank
very
you.
much.
Okay, so now we have lunch.
and we will start the first part of our special session on intelligent methods for data analysis and computer-aided software engineering. So the first presenter will be Dovilė Kuzinienė. Okay, so please you can start.
Okay, you can see well, it's different. Okay, so I am Dovilė, and I want to present autoencoder as feature extracting technique for financial distress classification. This topic is widely researched, a special part of financial distress, because there are a lot of related parties were interested in this topic. There is credit scoring agencies, financial institutions, stockholders, and so on. I'm looking from a little bit different perspective due to I am involving a lot of indicators, not only the financial records or financial ratios, but such soft indicators from taxes, employment data, and so on. And my goal is to predict, of course, if a company will have financial distress or not after the year. So this is the data. It's Lithuanian enterprise data for a period 2050 to 2022, and the half of 2022 is used for the test data. Everything else is used for the train data. Target is bad situation of enterprise, and it is found in Registra Centra, state tax agency, and court. Implemented 972 different features, and of course the case is not balanced because we have to balance it. Yeah. And methodology that I applied in this research was to split, of course, first to train and test data, then we normalize the data, and we use balancing technique, SMOTE and C, because we use this technique because we have some indicators which is binary, and SMOTE and C technique is used for binary and continuous indicators. Then we use autoencoder as feature extraction technique and classificational methods. There is additional feature selection because some classification methods like logistic regression, random forest, or XGBoost offers some kind of information which variable is the most important, so we can redo our experiment. And we see the results. So what kind of methodology we used, techniques? We used common used methods, logistic regression, decision trees, random forest, XGBoost, and of course several neural networks. You can see evolution metrics, and we applied additionally effectiveness criteria, classify at least half of the bad cases and good cases, so that is 1,000 for financial distress and 35,000 for non-financial distress cases. Here you see autoencoder structure. It's neural network with input and output layer, encoder, decoder phrase, and we use feature extraction because we use the middle layer, the bottleneck, and that's how we extract the features. So how the research process is? We have different types of data, board, firm type, sectors, macroeconomics, and so on. We know the quantity, how many indicators we have in each set of, and we use two different strategies. The first strategy is combine, merge everything, and extract features. So we see our 1A, 1B. One is how many hidden layers is in. The next is with 2 or 3, or A, B, C is how many features are in bottleneck. And the next strategy is we not merge everything, we separate from different data sources, and we combine these different autoencoders together, yeah? And C1 and C2 differs because we look on correlation, and we decide how many features have to be in bottleneck layer, because we assume that it has to be not correlated. We use a benchmark model. This is difficult because when we use only Lithuanian data, and for that reason we choose to use only financial ratios, because in literature is that common thing, yeah. So we separate 5 different benchmark models, only with financial records, only financial ratios, and combination of financial statements, records, and ratios, and application of this second strategy. When we define 2 autoencoders for financial records and financial statements separately. And here you see the results, and the best benchmark model from our score is with 60 features and only financial statements data, that including and records and ratios. Yeah, and for F1 score is 90 the best, and it's a different model. It uses only financial ratios. Okay, so when we do the research, we implied the effectivity criteria, and if we do all experiments, we have 23, but after implementation effectivity criteria, we see that other autoencoders experience wasn't right, and we don't have any experiments with that. And we can see the benchmark score from F1 perspective and out, and we see very clearly that strategy number 2 is better, and we have the best scores. And for example, if we don't implement the strategy, the benchmark model will be better than combination of all data sources. And here you see in numbers, yeah, but the best is was the S2 strategy, neural network with 2 hidden layers. And here you can see additional, like that was additional feature extraction made it, and you see that logistic regression with coefficient, var import, or var ANOVA. And if we separate kind of that methods, and you can see that the same 10 bests is from strategies number 1 or 2, and not from the first strategy. And there's extra results. We combine the same strategy for PCA, and we see that to make combination in PCA for data sources is better than combination everything at once. So conclusion will be that it is better to use separated autoencoders and then merge together, and better to use to check with correlation, because the results not much differ, but we have not have so many powers, computational resources. And the best course was with neural networks. Yeah, and modification, for example, logistic regression with coefficient was not necessary. It was really the same. So thank you.
Okay, thank you. And do we have any questions from on-site participants? Okay, I have one question. So, okay.
I will be the last.
Oh, okay. So, what is the most suitable method for predicting the bankruptcy of companies in the Lithuanian market, according to your study research?
According to this research, is the strategy number 2 with neural network. It is not deep, and you can get a good result. But if we
But it is with precision 99.34%, but it is much more precise than number 3 or not?
Yeah, but I look from Paul's perspective because I want to predict very good and financial distress and net distress, not only one part of it.
Okay, more questions? Okay.
So, thank you. Generally, looking at those nice results, I could say I'm just looking at the white noise. So just why should we compare if we're just having random errors, I suppose, because you can see 99% as precision. So what is the motivation of choosing any of them if they are so close to each other at precision, if in respect to precision? Okay, but I have more specific questions. Can we go back almost to the middle? And you have said that you have a bottleneck layer, yes? So what was, again, the motivation, the logical, having to know that bottleneck? Why do you have to have, yes?
Because it's extract the features. From 972 features, I extract to 64, 32, and all the 32 I use in my method. Yeah, in this case, with strategy 1, I use 74, or with strategy 2, 40.
Okay. And so at the last layer, so we have extracted already the features.
Yeah.
And those features correspond to any physical equivalent feature in the real life, or they are just combination of the output layer?
This will be a combination of all the features. Yes.
So they don't necessarily have to have some meaning, financial meaning. So
it will have that. This says that you can combine all financial statement ratios to one. To one data set and to combine and get eight features and lie in your...
Yeah, but you have different measurement units. How you can combine very different in nature, I don't know, okay, the types of, I don't know,
maybe
initial... Yeah, maybe.
I normalized, yes,
first.
Yes.
Okay.
First of all, I normalized.
Then it's... Okay, thank you.
Okay, thank you. More questions? Okay, no more questions. So thank you very much for today. Congratulations, this is your certificate. Thank you very much. And now we should have next presenter, Eglė Grigonytė. Okay, we have an on-site presenter. The floor is yours.
Hello all. The topic we have been working on for the last 2 years is scope assessment methodology for the Agile project. The idea for the topic came from the practice. Companies often get lost between waterfall and Agile projects. In order to apply Agile, they often rush and ignore very important details. One such important part is project scope assessment. The main success factors of Agile are involvement of a client and the team in requirements gathering, regular, usual bi-weekly review of results and feedback providing, and flexible adaptation to changes. If waterfall made it possible to pay a lot of attention to the analysis phase and thus gives us more accurate assessment of a scope, when Agile implementation does not have such an opportunity. We see that models such as UML activity, use case, SML requirements have been used in design for a long time, but they are being pushed out of the market. However, their benefits in project planning are great and can help solve emerging challenges in ineffectiveness. During the analysis, attention was paid to subjects, modeling standards that are suitable for the initiation phase of an Agile project, and existing methods that help to more accurately estimate the scope of a project. Various methodologies can be used to estimate project scope. They define the principles of how to deal with large projects, scaling and requirement gathering. Even though initially they were dedicated to waterfall projects, the main principles can be used in Agile projects as well. We need to pay attention that these methodologies typically require a more rigid and structured approach to requirements gathering, which may not align with the flexible and iterative nature of Agile development. So, how we can deal with that? We think that models that are used in waterfall projects can bring a lot of benefits that can be applied in Agile projects, such as visualization, flexibility, traceability. Combining principles from project scope assessment methodologies and modeling benefits can lead to successful planning in Agile projects, as long as we are used in a lightweight and iterative way that supports the principles of agility. These principles are combined with the proposed methodologies below. To solve the challenges of assessing the scope of a project, a methodology has been proposed. It always the necessary information to be collected and evaluated in one place. The main goal is to avoid multiple sources of requirements, Excel files, and information traveling through the emails, and it can be extremely incompetitive in time. What are the preconditions? Requirements are collected during the Lean requirement workshop, identifying product charter, user roles, user journey map, story map, and other models. After the session with the client, requirements must be collected, reviewed, and the proposal with the estimate should send to the client. Collecting and consolidating the requirements is a complex process. This process is complicated by the fact that people can see and record different things while participating in the workshops. The collected information depends on several factors: the process of gathering requirements in the company, the competitions of the project team members, the knowledge base of the subject area. It's complex. If the requirement gathering is struggling, the methodology helps to tighten the collection and focus on the most important parts. The goal is to have an alignment on the scope. The methodology consists of an algorithm. It has 8 main steps. The first 2 steps allow us to identify the problem of a project and to define the expected results. These steps are directly related to the project character in the Lean requirements workshop. The first step is to choose which assessment methodology the user wants to use. Example, story points. It does not impact the algorithm. Steps 4 to 6 are intended to evaluate the product from different perspectives, including functional requirements, non-functional, and architectural requirements. The user may choose what kind of information they want to upload. Example, models, Excel spreadsheet. Team members can be familiar with UML, SML, story map. It can be an internal agreement as well, where team members will write and collect using different methods during the workshop. The 7th step is the identification of risk and dependencies. The 8th step is to add the estimate to all available requirements and any additional information what is needed to calculate the scope of a project according to the formula. As you can see, the functional requirement steps and estimation step are the most important. How make them work efficiently? Let's see some details. Once we are talking about automated requirements gathering from the models, we have in mind several models: SML requirements, UML use case, activity, class, story map. Based on the rules, elements from the models are combined in the requirements. The user can choose which models to upload for requirements automated identification, keeping in mind that models can be prepared by different team members. There is also an option to upload a list in Excel format. Experiments with real projects have shown the need to identify overlapping of requirements. A lot of attention is paid to this because it helps to unify the vocabulary of the domain area, eliminate redundant requirements, and properly group and decompose them. On the right side, you may see examples of automatically formed requirements with some additional metadata. After collecting the requirements and other additional information, a project scope assessment is performed. Each requirement gets level of clarity. It is identified for each requirement. There are times in project when a certain requirement raises a lot of questions and ambiguities that can only be answered after the implementation of other related functions. So levels could be from 1 to 4. There is 1 very clear, 4 is not clear, and raises many questions. Also, priorities and dependencies are identified and estimated as well. When we calculate the scope based on the formula can be seen on the slide. Experiments. The experiments are dedicated to answer this research question. Can the methodology improve the overlap of gathering requirements? Is it possible to improve the project coverage by the requirements and have better alignment on scope? Conclusions are the biggest overlap of the requirements is in SysML requirements, story map, use case models. Both projects help to understand that one model, the primary one, cannot support all the functionalities or all the specs. Additional models can identify either the new requirements or clarify decompose the existing ones. Manually supporting several models would be an ineffective decision, but automated requirements gathering eliminates manual work and helps to read the requirements even if a user does not know how the model is constructed. A project scope assessment is a number that is meaningful to the team and the client of a project. Even the same team can have different approach when we estimate two projects. Teacher sizing and story points enable a comparative approach in the estimation session and allow user to compare and estimate. In Agile project scope assessment can be challenging. The pressure to have a quick estimate of a project scope can give negative consequences and project execution. Automatic extraction of requirements from models and identification of where overlap saves time and ensures that even people without knowledge of requirements gathering will be able to understand the express needs and approval. Future research will be aimed at improving the scope assessment, and priorities should be reflected in resource planning, time planning, roadmap creation, and the identification of risky areas of a project. Thank you.
Thank you for the presentation. Do we have questions?
Maybe you can join my colleague, Lina?
Sorry?
Maybe you can join colleague
Okay, of course.
from Zoom.
I'll try. I don't know, but I'll try.
Okay, she helps me answer your questions.
Okay, no problem. So maybe no questions, right? Oh, Lina. So, Lina. Hello, Lina. Are you here?
I'm here.
Oh, hi, Lina. How are you?
I'm good.
So, okay, I would like to ask one question. Okay, what could you please name the essential advantage of your proposal instead of, for example, well-known user requirement specification software tools like IBM Doors or similar?
Yeah, so the main idea, the challenge that we came here is that in my company that I'm working with is a project company, and we gather requirements and need to do the proposals. And what we're missing in Agile projects, that we have an extremely small amount of time, is basically half of a day, to make a proposal. And usually what we do, we are missing scope details. And we believe that what we had previously, like you mentioned, IBM Doors, it's basically a tool, but not the process, how to educate team members to dive enough in details to be in extremely good alignment on the scope, and based on that to make a good proposal. So it's basically not how the requirements are structured, but basically how we are gathering them, what kind of information we are adding there, and how we are happy with the result. So that's maybe the main case.
Okay, one more question.
Okay, okay, thank you again for the presentation. Can we go back to the slides that the few examples were discussed? I think almost at the very end. Yeah, this is it. Can you discuss a little bit more about these two projects as an example? Yeah. So what should be the outcome, and what was the problem, and what was the outcome? So can you discuss a little bit more on this example?
Yeah, so there are two quite different examples. The first one that we took from the company is a greenfield project, and it's slightly different once you have a legacy ones, and you have lots of ideas, and you have to agree what is the scope, what is the MVP, what are the priorities. And that was the idea how different team members like project lead, product manager, BA, architect can see the same greenfield project, for example, for MVP. So we took it and we paid attention into the details in the models, what kind of ideas they succeeded to put there. The second one was slightly different, is improvement of the existing system, legacy system. It means that you cannot rely only on the idea or the future thinking how the product will look like, and you have to pay quite a lot of attention into the details like integration ones, existing system, existing environment. And there are people who are working on the workshop with the client dealing completely with different information and paying different attention in the details once they are gathering the requirements. And it was interesting for us to see where were the items, or at least the steps, where they paid attention the most. So that's why we took two of them into the paper, thinking about completely different aspects. One team members are paying attention based on the project type.
Yeah, thank you. And what was the format of your reply, the results? So you summarize the results in some kind of way. What was the format of replying them? You sent a few of the diagrams, or what was the reply?
Yeah, so basically we are internally as a team that we're preparing the proposal. We have the diagrams, we have a list, and we have in a couple of cases we have a story map for Agile project, for example, in the first case. And at the end of the day, we are preparing internally the Excel spreadsheet with the additional information and the list of requirements grouped and with the estimation. And next to that, we are preparing the proposal to the client with, of course, all the information that is needed for payment, timelines, FTE, and similar things. So usually what we did in these cases, we added diagrams and the additional agreements that came up from this question, not from this project, so just not to be tied only with the proposal, but at the same time with additional information to be sure that not only us, but the client as well clearly understands the scope and knows what to expect at the end of the project.
As a participant of this presentation, I also would like to see some kind of visualization of the results as well, because it's pretty hard to understand the net result of your scope then.
Yes, I understand. It's basically just a matter of time, and we added those examples in the paper, the list, the estimation, the additional information. So basically, not everything came up.
Also introduced the same information, excluding the sensitive information regarding the clients. Okay. Thank you. Anyway.
Thank you.
Okay, thank you, Lynn. Thank you, Egle, for presentation. Okay. This is certificate for you. Okay, thank you. And
Now we will skip the presentation number 3 because we do not have presenters on site nor online. So the next presentation, the privacy risks in German patient forums, a near-based approach to digital twins. So Sergey, will present, or Simon? Oh, okay. I thought that it will be on-site presenter. Okay, so Sergey, the floor is yours.
Can you hear me?
Yeah.
Okay, great. And can you see my screen now? Okay, great, thanks. Oh yeah, hello everyone. My name is Sergey Schundkamp and I'm research assistant at the University of Applied Sciences and Arts in Bielefeld. And today I will be presenting our publication, Privacy Risks in German Patient Forums, an identity recognition-based approach to enrich digital twins. So this publication was jointly submitted by my colleague Frederick Simon Bäumer and myself. Yeah. So first I would like to introduce the motivation for our research project and also this publication. So in 2017, several newspapers reported that a fitness tracking app called Strava revealed secret locations of different army bases. And basically, these army bases were not shown, for example, on Google or Apple Maps. And by analyzing the heat map, which was provided by Strava, military analysts were able to detect sensitive informations, so the movement of military personnel, and therefore different army bases, for example, in Syria and Afghanistan. Yeah, and this leads us basically to our research project, ADRIAN, which stands for Authority-Dependent Risk Identification and Analysis in Online Social Networks. So our goal is to develop a framework for analyzing threats to different users on social networks. So I will explain our approach based on this graphic here. So consider a random internet user at the bottom left who publishes different content. And according to Data Reportal, every internet user in 2022 had over 7.5 online social network accounts. So for example, Instagram, Facebook, or Twitter. And over the time, this results in a very large data source, which consists of profile data and different content like text, video, and images. So, and on the other side, we have different modern threats. For example, like the de-anonymization, where the attacker links different accounts on separate platforms to reveal the user's identity, or like the social engineering, where this public information is used to build trust with the user and then to manipulate the user or to perform some phishing attack, for example. And as for doxing, in this case, for example, the information is published online with the intent to harm the person. And we cannot stop the user from posting, and also we cannot stop the attacker from misusing this information. But our goal is mainly to analyze this information, which is available, and to warn the person once the person is sharing too much information or too sensitive information. And for this reason, we perform a so-called threat analysis, where we first create the digital twin, which is mainly a cross profile of all the profiles which we can find. And then we build a threat model to detect several threats, like, for example, social engineering or identity theft. So basically, this leads us to the quantification to which extent a user is vulnerable to which threat. Yeah. So next, I would like briefly to explain what kind of data we actually analyze in our project. And the first step is like to match available user profiles based on some structured information, for example, like the name or the username and the location. But our focus lies also on some structured data, where we extract a lot of important information for us. So, for example, like texts within this publication, or also like images, which was what our recent publication about. So here is like an example where we have millions of images where we analyze these images, for example, to find different characteristics for a person. So the first step is like to detect, are there even persons on this image? And if yes, how many? So this vision language models, they usually work only reliable for one person, for example. And furthermore, you can then detect what is the gender of the person, what's the hair color, or what's the skin color, for example. You can also detect, like, is the person wearing glasses, or does it have a marriage ring, for example, which would lead to, for example, to some family members, or at which place this person is currently. So here it's like we can't see anything, but there are images where you, for example, see the Eiffel Tower or something else, and the model would, for example, tell you that this is like in Paris. And so based on this profile information and then this analysis of unstructured data, which is posted by the user, we aim to create a so-called human digital twin. So what is actually a digital twin? So digital twin is widely used in different domains, such as manufacturing, aviation, and medicine, for example. And in medicine, we also speak about a human digital twin, where the approach is to build this digital twin for different types of analysis. And for our domain, like the social networks, there is no standard definition so far. So in Adrian, the human digital twin is defined as a digital representation of a person instantiated through available web-based information. And we use this human digital twin to store and analyze relevant information of a person. And in the last step, like the measure is the vulnerability of a person to several threats. So here on the right, you can see basic example where you first have the different social networks like Instagram, Twitter, and so on. Then you would match the data like the username or the biography and the image. And if you then get this group cross profile, then you would enrich it with even more data like the profession, health data, characteristic to get a most complete digital twin, which you actually can get. So next I would like to present our approach to extract the German medical entities from user-generated posts. So we know that this is a very basic approach, but it is essential for our project, for example, to match data from different social networks. So you can basically use this or extract these entities from user content, for example, add some time frame to them, and then match based on the time and when the entities were basically posted to get sure if this is the same profile, for example. But you also can add some relationships, for example, to these entities and to use them to validate and extend the digital twin. So in the first step, we basically create our own data set. And here's like a small example. It's in German, like I had fever. An ultrasound was done by the doctor. And later I was prescribed omeprazole for treatment. And here we have like the entities like fever. This is a symptom. And like the ultrasound, which is the diagnose or the diagnosis device, for example. And then the omeprazole, which is a drug. So we use then this data set to fine-tune existing models, like, for example, the German BERT model or the XML Roberta model, which is a multilingual model. Yeah, and basically we then optimize the loss, so based on different parameters, so to get the best results. So as for the data collection, we have identified a German patient forum, which had active posts for more than 10 years. And for us, it is important to use user-generated content, since this is also what social networks are usually about. So basically, we want to use these models later on also to analyze content from different social networks and not only from German patients forums. And we acquired the data on 11 January 2023. And here you can see some descriptive statistics about the data. We have slightly above 300 topics, then nearly 1.5 million posts from more than 100 users. There are users which are not active, but there are also users which have like 10,000 posts. And this is like the base for our annotation. So we defined 6 different entities which were particularly interesting for us. We have the anatomy, so basically some body parts, and like the diagnosis, as mentioned before, like for example, ultrasound or the electrocardiogram, and then diseases, some drugs, symptoms, and some treatments for the diseases. Yeah, and after the annotation, which we performed on like 2,700 sentences, we had a total of 6,949 entities. And if we look at the distribution, so the data set is very unbalanced. And we can see that like the treatment, drug, and the diagnosed entities have fewer instances, while like the anatomy, disease, and symptoms have much more instances, for example. Yeah, so as for our model training and the results, so as mentioned before, we used a German model like the German BERT and a multilingual model, the XML Roberta one. And yeah, did the model training with different parameters and tracked this with weights and biases for the parameter optimization. For the complete setup, I invite you to read our publication. The data set was split into 80-20% split for the training and for the testing. So we have slightly above 2,000 sentences for the training and 569 sentences for the testing. And as for the results, it can be seen that GBERT exceeds like XML Roberta in the one score for the anatomy, diagnosis, and the disease and the symptoms and entities, while yeah, XML Roberta performs better for the drug and the treatment entities. And it can be seen that the German BERT performs better on entities which have actually more instances, and XML Roberta performs better on entities with fewer instances. So as for the discussion and the future work, so we basically developed a German named entity recognition dataset for our project, with which we can now perform basically health information analysis. So based on these 2 models, we can extract relevant entities from user-generated content. And yeah, we also currently experiment with like new large language models like this Llama or Falcon models. But these small models like German BERT or XML Roberta are still very suited for named entity recognition. And if you fine-tune them on your own data set, they perform a lot better like than these new models, for example, which are also not like suited for named entity recognition. And for the future work, so our goal is like to also extract relationships within the entities, for example, like you can see here, like say ECG can diagnose a stroke, for example, and a possible treatment is like the fluoxetine. And then you can, for example, filter for like the stroke and get all the connections within the other entities. But it's also important for us to, for example, to analyze how the digital twins in our graph are related to these different entities. So, for example, that there's, for example, a person who has a headache, then it gets diagnosed and suddenly he has a stroke. This would also be available information for us to enable the exploration of these relationships for our project. So thank you for your attention, and if there are any questions, feel free to ask.
Okay, do we have questions from on-site? Of course we have.
Okay, hello, thank you for your presentation. And I have a few questions. And what was your platform? I mean, what language did you use to develop your product? So what was the platform, or .NET, or what was language you were developing this twin human, your project? Okay, the language.
So for our project, we simply use like the Python for the machine learning and so on. But as for the digital twin, this is basically mapped as an ontology. So it ensures like the structured representation and interoperability between the different systems. Yeah, and we use like existing ontologies like schema.org or friend of a friend. So we can use these established standards basically. And if there's like a new property for us, we simply add this property.
Looking at the results, this is another question, okay? By looking at the results, I would surprisingly they are too high, unbelievably precision. So it would be very interesting, maybe next presentation, to compare confusion matrices of training and testing. It would be very nice if you would, let's say, extract one feature and you train for that feature and test that feature. I would like to see the confusion matrix, because I would like also to see sensitivity data, which is very important when you deal with medicine data. So it would be very nice. It would be very nice.
Thank you of your advice. Yeah, next time I will put like a confusion matrix in the presentation and test for this.
Nice. And by the way, so the future direction you were saying about the stroke, for example, or a headache. So your tool is going to, I don't know, how it's going to include the feature of headache to the person or identification, or how you're going to say that this person tends to have a headache, or regarding his, I don't know, some features is going to have a headache, or what? So what is going to be the part of that?
Yeah, this is like the point which we are currently working on. Yeah, this is like not that easy, as you said. This could be like a triple, where, as you said, like person has a symptom, headache, but also how we do connect like all the entities to this person. Yeah, we are currently working on this, and I will be happy to present this approach like next time.
We'll wait for the further results, of course. Okay, thank you.
Okay.
Thank you.
Do we have more questions? Maybe scientific supervisor would like to ask something? Okay. Okay, it's clear. So thank you very much. Thank you.
Thank you.
Have a nice day. Certificate for Frederick Simon Barrow. Okay. So we have the last presenter of this session. So Samuel, can you hear me?
Yes, I can hear you.
Okay, great. So could you please share your presentation, and the floor is yours.
Okay, thank you. Okay, yeah, good afternoon. My name is Samuel Ajibade from Istanbul Ticaret University in Turkey. And I'll be presenting on application of machine learning in energy storage, a scientometric research of a decade. Okay, and the abstracts, the publication trends and bibliometric analysis of the research landscape on the application of machine learning or deep learning in energy storage research was examined in this study. And the Prisma technique was employed to identify, screen, and filter related publications on the machine learning and energy storage research. About 969 documents were recovered, which comprised of articles, conference papers, and reviews published in English. Now, the high publication and citation rates were ascribed to the research impact. We also looked at the co-authorship collaborations, and also as well as the source and title journal reputations, multidisciplinary nature, and research funding. Further analysis of the research landscape showed that this research is currently and largely focused on the application of machine deep learning for predicting, operating, and optimizing energy storage. Now, introduction. Energy is regarded as one of the most crucial resources which is needed in social, economic development and long-term infrastructure development worldwide. And millions of people actually, from recent information, still lacks access to electricity in so many places all over the world. And that is why the UN Development Goals was introduced in 2015 to address the variety of concerns, which includes also lack of electricity. And energy being the goal number 7 of the UN SDG aspires to ensure that everyone has access to reliable, affordable, clean, and modern energy services. And it is hoped that by 2030, there will be a significant increase in the global percentage of renewable energy sources in the world's energy mix. Okay, and so these are related works. The use of computational methods like machine learning for energy storage study has gained popularity over time. According to Luxton's definition, machine learning is a key component of AI that enables computers to learn how to carry out tasks without being explicitly programmed. And also, few scholars have reviewed the many advancements in this area. The research on the use of machine learning in the modeling of materials and interfaces for energy conversion and storage has been mostly reviewed by Arthread. And similar to these, Quine and Son evaluated the most recent developments in machine learning investigations on MXNeses for energy storage and conversion. Also, the authors, Barrett and Aruna, also emphasized on the existing capacity of ML for application in data analysis, and they compared theirs to the computational quantum mechanical model techniques like density functional theory. Okay, and these are the methodology that was used in this research. We use the PRISMA method, which is used to find, screen, and filter published documents from particular scientific databases. So we made use of the Scopus database. And the published documents on this research were identified using the title ABS key. That is, these are the search criteria that is written there. And consequently, the document screening process was performed to eliminate the non-peer review, duplicates, and unrelated, as well as non-English publications from the recovered list of documents. So at the end, we were able to get 153 documents from the list of 969 published documents after screening and then filtering all the papers that we actually need. So using the published data recovered from Scopus and scientometric analysis, the analysis stage involved looking at the trends in publishing and the research landscape on the machine learning energy storage research. Okay, and these are the results that we have. We have this first figure 1 shows the publication trend. It actually shows the plot of the total publications and citations on machine learning and energy storage research. And the analysis of the general publication shows that the number of published documents increased from 3 to 385, as we can see in the image. And then in the figure 2 shows the distribution of topics for publication on the topic, which was gotten from the Scopus database within 2012 and 2020. That's 10 years, a decade. And then we can see from there that actually engineering, just a moment, please. The engineering actually has 25.7. And also we have other ones, the mathematics 7.9, material science 6.8, chemistry, and so many other ones. Okay, so these are the distribution of subject areas for machine learning energy storage research. Also, we check the top cited articles. So this table shows the top 5 top cited articles from 2012 to 2022. We have Foley and Lay. The source title Renewable Energy, they had 892 citations, then followed by Oran Grau, which has 792 citations, then followed by Un Jiang, 340 citations, followed by Kemali and Kolimea, 308 citations, and then Chen and Wu, 235 citations. So those are the top 5 cited articles in this subject. Okay, then we have the top authors, the top 5 most prolific authors in this area from 2012 to 2022. As seen, the authors have written at least 6 publications on this subject. And Yan Zhu, who is based in Singapore, has 9 publications. And our work has received a total of 100 citations. And then followed by Choi DH, followed by E, and Ram Prasad, and then Benedri. So these are the top most prolific authors in the area of machine learning and energy storage research. Also, we have the co-authorship network visualization map. So this shows the co-authorship network visualization map for this research. The findings indicated that 61 authors out of a possible of 3,166 have 5 or more articles with more than 50 citations. So this visualization network shows that for the published documents. And also we have the top affiliations. The top 5 most active affiliations in the MES research are presented in this. And we have the Tsinghua University in China, followed by the Chinese Academy of Science. Then we have the Ministry of Education China, and followed by the Nanyang Technological University in Singapore, and then the Shanghai Jiaotong University. So that these are the top 5 affiliations on the subject of machine learning and energy storage research. And then lastly, for the results, we have the top active countries. So the top 5 most active countries conducting this research globally at the moment. We have China, which tops the charts, followed by United States. And then we have United Kingdom, followed by India, and then South Korea. So these are the top 5 most active countries conducting research in the area of machine learning and energy storage. Okay. And then in conclusion, this study looked at the bibliometric data and publishing patterns related to the application of ML in energy storage. And the Prisma method was used to locate and evaluate the filter published documents. So we can see that according to a subject area study, this MES research articles are included in a number of categories, including engineering, energy, computer science, and then it actually shows that this field is a multidisciplinary and wide range of things. And in the future, okay, and so in the future, with this research will concentrate on ML and computational applications for synthesis of energy materials, analysis of energy efficiency, monitoring and control of operational systems. Okay, thank you very much.
Do we have questions from site users? No. Okay, so thank you very much again. And okay, we have one question.
Okay.
Okay, so hello, thank you for presentation. And can you discuss a little a little bit more about your, I don't know, this is your tool that uses that Prisma method, but is it, have you created an API, yes, that, let's say, that uses the, which one, the method of IE method you're going to use, again, artificial machine learning, which method you're using to scan the publications? Okay, can you go to, I don't know, the third one or the fourth one slide? Can you go there?
The methodology here, the slide.
Might be so.
The Prisma.
So where? Yeah. So what is the Prisma? Yeah. What is that? So this is a machine learning method or not?
No, it's not an no API was.
Method, please. Machine learning method. Which are you using to scan the publications and what?
Oh, you mean to filter the publications from the Scopus database? Okay. Getting the publication from Scopus.
Right. So where is that method again?
Here's the method. This. Here. This method.
All right. So have you implemented yourself or using Python, of course, yes, or what? What software were using?
No, I did not use Python. I only filtered the publications from the Scopus database. So I downloaded the Excel file and then I filtered and then I used that to. I used VOS Viewer.
Okay, so
yeah, I use VOS
right.
Viewer software so to get the results. So I just filtered using the on the Scopus database. I did that manually anyways. So I didn't use any API or any programming language like Python.
It sounds not very great at all. So this is just advanced literature review. So you must start creating your software, your tool. Because at the present state, it's quite weak, not impressive at all. So you must catch up with better solutions. Okay, so it has to be automated.
Okay,
It has to be automated. For example, you create your API. The user inputs some keywords of his desire, and your software tool provides with this kind of review, okay, in automatic fashion. So okay, so.
Okay, I will. Yeah, I will.
So sorry for being so straightforward here.
yeah. I mean, I appreciate that. I appreciate that. Yeah, thank you very much, and I will.
Thank you very much. And we have a final presentation. The Martins, are you here?
Thank you very much.
I'm here. Thank you, Samuel.
Yeah, Martins, we can't hear you.
Oh,
now we can. Okay, so the floor is yours.
Okay, so I'll share screen and that. Hope you can see my screen. So what we are talking today is user interaction response-based knowledge discovery framework. In a world filled with information, where content creation is prolific and data is generated at an unprecedented rate, the challenge we face is to transform the vast sea of data into meaningful knowledge. Today, I present a framework designed to address this very challenge. This framework presents a meta-level approach, laying out principles for the design and implementation of knowledge discovery systems. So, knowledge is all about turning data into actionable insights. In a world where information is abundant, the ability to extract valuable knowledge from the vast sea of data is more crucial than ever. Think of it as a treasure hunt, where data is the raw material and insights are the hidden gems. And the World Economic Forum of 2022, there was a profound statement: we might be drowning in content but starved of knowledge. This perfectly encapsulated the challenge we face in the digital age. We have more data at our fingertips than ever before, but extracting meaningful knowledge from it remains a formidable task. The shift towards a knowledge society has only reinforced the importance of knowledge, and this society intellectual capital takes precedence over physical assets. It's not just about having data, it's about understanding it, using it, and creating knowledge from it. And that's where knowledge discovery comes in. It's the process of mining the data to find those hidden insights. It's about connecting the dots and anticipating change and making informed decisions. Knowledge discovery systems are the backbone of data-driven decision-making. They're the tools that allow organizations to unlock the hidden insights within their data, transforming it into actionable knowledge. The knowledge discovery systems usually consist of technologies, data storage, cloud computing, machine learning, security, legislations, and these components together create a robust knowledge discovery ecosystem. But it's essential to recognize that developing such a system is complex and time-consuming. This is where knowledge discovery frameworks step in. The challenge lies in the sheer complexity of developing these systems. Organizations are dealing with massive amounts of data, diverse technologies, legal regulations, and the need for robust cybersecurity. This complexity often results in missed deadlines, outdated technology, changing priorities, increasing competition. In the face of these challenges, organizations find themselves at a crossroads, either adapt to change or stick to the original plan. This is where frameworks like ICIST KDF come into play, offering a structured path. The need for a framework becomes evident when we consider the complexity of knowledge discovery systems. These systems involve a wide array of technologies, processes, and data sources. They aim to transform raw data into actionable insights that can drive the decision-making and innovation. However, navigating this complexity can be a daunting task. Without a structured approach, organizations may struggle to develop effective knowledge discovery systems. That's where frameworks come in. Think of a framework as a roadmap. It provides guidelines, best practices, and structured paths to follow. Here are the few reasons why frameworks are essential. Speed and efficiency. Frameworks streamline the development process. Flexibility. Frameworks offer flexibility to adapt to changing business goals. Reduced errors. Standardization. Support for architects. And there's a limited number of knowledge discovery frameworks, and they often cater to specific domain. This scarcity emphasizes the need for frameworks like ICIST KDF. A framework isn't just a set of rules, it's a powerful tool that can help organizations harness the full potential of their data. The heart of knowledge discovery, the technologies that power it. In our evolving tech landscape, we're dealing with data storage challenges, streamlined data processing, distributed file systems, cloud computing, and each of those elements plays a vital role in building effective knowledge discovery system. The choice of technology can make or break systems' success. A crucial aspect of knowledge discovery, legal regulations, and security. In a data-driven world, we must consider data privacy and protection. Regulations like GDPR and CCPA set the standards, but those are not the only ones. Right now, every state is starting to present their own privacy frameworks. There is no specific one for the whole United States, and there is differences between the countries as well. And frameworks ensures that compliance is considered with these regulations, even as valuable insights are extracted from data. Ensuring data security is crucial. The ICIST KDF framework emphasizes the need for security measures, especially with the growing importance of cybersecurity. ICIST KDF is a 5-layered conceptual framework that separates technology, applications, and machine learning. It ensures flexibility in adapting to changing business goals and is designed to address the challenges described. This framework offers a structured approach to knowledge discovery system development. ICIST KDF provides guidelines for architectural planning and organization, making the complex process of knowledge discovery systems development more manageable. It's a valuable tool for organizations aiming to leverage data for better decision-making. This layer serves as the foundation for the entire framework. It encompasses various technologies and infrastructure components necessary for the operation of knowledge discovery systems. Key elements of this layer include tech stacks, operating systems, containers, communication protocols, databases. It also involves critical considerations like scalability, authentication, audit logging, and access controls. The tech layer plays a crucial role in ensuring the separation of technology from other layers, such as business applications and machine learning. This separation allows for flexibility and adaptability to changing business goals. In the framework, we recommend leveraging containerization technologies like Docker and orchestration platforms like Kubernetes for flexibility and scalability. The tech layer is where data continuity, integrity, and availability are maintained, making it an essential component in the knowledge discovery process. These layers are crucial for providing functionality required by end users and organizations. It includes a wide range of applications, both web-based and mobile, designed to serve different purposes. The public applications within this layer are aimed at end users and customers. They may include user interfaces, mobile apps, and web portals. These applications are the face of the knowledge discovery systems for those outside the organization. The management applications are designed for internal use within the organization. They assist in managing and controlling various aspects of the knowledge discovery process, aligning with the company's business requirements. Both types of application layers are essential for ensuring the success of knowledge discovery systems. They need to be flexible, scalable, and capable of working with APIs regardless of the technologies used. It's important to note that while the number of users for management applications is limited and controlled, public applications may have an extensive user base. Therefore, scalability and load management considerations are vital for public applications. In the framework, we emphasize the separation of functionality between public and management applications to better serve the diverse needs of end users and organizations. Machine learning plays a central role in the knowledge discovery process. It empowers knowledge discovery systems to extract valuable insights from the user response data and improve decision-making. This layer encompasses a range of components, including algorithm registries, feedback data loops, third-party data sources, and user response data. The machine learning layer serves the purpose of developing, deploying, and managing machine learning models. Machine learning algorithms are tailored to the specific domain and objectives of the knowledge discovery systems. They leverage historical user response data to make predictions, identify patterns, and extract knowledge. Through machine learning, organizations can enhance their services, develop chatbots, and make data-driven decisions. However, it's important to recognize that the field of machine learning is complex and rapidly evolving. Finding individuals with expertise in data processing, statistical analysis, domain knowledge, and machine learning is a challenge. The framework acknowledges this challenge by separating the machine learning layer. This separation allows experts to focus on developing and optimizing machine learning models without being encumbered by the intricacies of technology and application-specific requirements. Conceptual framework, ICIST, is designed to address the complexities and challenges faced by organizations in the journey to extract knowledge from user response data. In practice, ICIST serves as a guide for the early stages of knowledge discovery system development. It plays a pivotal role in infrastructure planning, ensuring that technology management, public applications, legal regulations, cybersecurity, and machine learning seamlessly integrate to support data-driven decision-making. Suppose an organization aims to enhance its customer service by analyzing user feedback data. ICIST would provide the blueprint for structuring the technology layer, enabling scalable and reliable data storage and processing. It would also define the requirements for management and public applications, ensuring that the end user experience is seamless. ICIST takes into account legal regulations such as GDPR, ensuring that data collection and processing adhere to compliance standards. Additionally, it emphasizes cybersecurity, safeguarding sensitive information from threats. The machine learning, a vital component of ICIST, enables the organization to develop models that extract actionable insights from the user response data, further improving customer service and decision-making. Through the layered approach for ICIST, organizations can effectively navigate the complex landscape of knowledge discovery, streamline the development process, and harness the power of data for tangible business outcomes. The framework offers a structured approach to tackle the challenges identified in the presentation. It provides a meta-level perspective for designing knowledge discovery systems and emphasizes the importance of various layers, each with its unique role. The tech layer is crucial for ensuring the robust infrastructure needed for data storage, processing, and scalability. In an era marked by the growing importances of cybersecurity, framework dedicates attention to safeguarding data from threats and breaches. It emphasizes the significance of protecting sensitive information through the knowledge discovery process. The framework serves as a guiding framework for organizations seeking to harness the power of data, streamline development process, and improve services. In conclusion, the framework represents a comprehensive approach to knowledge discovery, aligning technology, regulations, cybersecurity, and machine learning to meet the demands of the knowledge society. By embracing this framework, organizations can position themselves in an increasingly data-centric world. Thank you.
And do we have questions from on-site users? Okay, we have one question.
Can you hear me?
Yeah.
Well, so could you please give us short examples? How did you implement your approach?
Okay, so an example from my professional background, by the necessity of creating an ad tech enterprise that means to be scaled in US, European Union, Africa, the whole African state, and a necessity to have it compliant with the different regulations. I would actually needed this kind of framework to create this backbone of the tech necessary to fulfill the requirements of all of those states. I said this is where I would have been willing to use it.
It was worldwide, not a small example.
Of course. Small market examples are a bit different because small SMBs are mostly for companies that do not need to have global scalability. Therefore, the potential of loads are a lot less, and therefore the necessity to be comfortable with a lot of frameworks is to a lesser extent. If we take Lithuania or Latvia, we do have to be comfortable with ISOs. We need to be comfortable with GDPRs and local legal regulations. But if you're taking into account global companies, then a lot of other legal regulations do come in mind, as SOC 2.1, CCPAs, HIPAAs, and other regulations of the world.
Okay, I have one more question. I would like to ask, does your framework will correlate with, let's say, existing kind of solutions, like, for example, Camunda open source solution for business rules discovering and processing, and, for example, like Disco tool, which covers process mining, all the, let's say, all the idea provided by by Professor van der Aalst 20 years ago. Will your framework will compatible and will cover kind of existing solutions?
Of course, since right now we're looking at meta level frameworks. Of course, this framework is adjustable to every specific need of not like every specific, but to your specific needs of your own organization's necessities. Therefore, definitely it is really possible to integrate the previous and upcoming changes in tech layers, etc.
Okay, thank you very much. Thank you for presentation. And now we will have 25 minutes time break, coffee break, and we'll return to the second part of this section, 15:45. Yeah, okay, thank you.
Second part of the special session on intelligent methods for data analysis and computer-aided software engineering. And I would like to ask for the first presenter, Tomas Adamkus. Yeah? Okay, the floor is yours.
Hello, I am Tomas Adamkus. Title of my presentation is Access Control Approach for Control of Management Platforms. This work I made with my colleagues Klaidas Klimakas, Rasa Brusgienė, and Lina Narbutai. All right, in Internet of Things we have cybersecurity problems. There are many cybersecurity attacks. For example, unauthorized access, data theft, cyber attacks, inadequate data encryption, and all these problems, security problems, make the user can access its services security, and it is big problem. So. In Internet of Things, we have three different layers. It is application layer, network layer, and perception layer. And in all three of these layers, we have security challenges, different security challenges. And depending of what it is a security challenge, it can be found in just one layer, and can be found in all three layers. Solving security problem, we proposed access control method with new option. It is risk security score. So this risk security score we can calculate assessing environment context. So this method becomes dynamic method, because the classic methods which we have, they are static. And in this method we can dynamically assess an environment context. The administrator adds rules, and using risk score and the rules for different users and services, we can calculate and make access to the service or not. So user sending request, and from this risk score can access service, or it can be denied for him. All right. To calculate riskiness, we're using different attributes. It is resource sensitivity, yes, which service I want to have, impact of the action, what I can do, who can do this impact, and riskiness of the context. Thank you. I need to talk to a microphone?
Yes.
All right. All right. Now we have formula which using we can calculate riskiness of the context. It consists of context condition riskiness. They can be different, and we dividing it from a number of context condition. And very important part in this one, we can have two different situations. It is typical situation when we have typical conditions, and in this situation we assessing riskiness of the context. But can be situation when it is called critical situation, and in this situation can be, for example, problems with person health, yes, and it is a very critical situation, and we don't assessing environment context, just assessing the rules which are added by administrator. Now, for calculation we have three different attributes. First of them is rescue sensitivity, and we, for him, adding different values. resource sensitivity can be insensitive disorder. It is 1, sensitive resource it's 2, and very sensitive resource it is 3. The same situation is with impact of the action. We add 3 different values: low impact, moderate impact, and high impact. It is 3. And just 2 situations, 2 values for riskiness of the context. It is normal riskiness and high riskiness, 1 and 2. And using these values, we can calculate final risk score. It consists of effect of action, resource sensitivity, and riskiness of the context. And we have 5 different levels. First of them is low riskiness. It is from 0 to 3,6, and the highest riskiness it is from 40,4 to 18. And using these means, we can assess the riskiness of the context. Now we made the prototype to research our idea. All right, it consists of Raspberry Pi 4. There is installed our system and calculation model. To Raspberry we connected ASP8266 controller, main controller, and to this controller we connecting different controllers with sensors, outputs, devices, and so. All devices are connected to Wi-Fi network, and we have a computer to add administrative rules for administration of this system. So all these devices are connected to Wi-Fi, and it is our prototype. All right, in prototype we are using 3 different context conditions. It is daytime. Night it is more riskiness. Yes, when we making request in day it is less riskiness. Network, local network or wide area network, it is different riskiness. And location, Lithuanian or other countries, it can be more risky or no. So 3 different conditions. Devices which are connected to ASP model are controllers with different sensitivity. It is medium, large, and small. Action, what can they do? It is rise gate in garage, get status, switch, fireplace, alarm of the house turning on or off. Effect of riskiness with these 3 values. What about I talked? They can be 3, 2, 1, depending from the controller, action, and the user. Imitation in our prototype, it is buzzer, rise gates, different colors LEDs, and informative info to monitor if I want to have some info. We made researches in 3 different scenarios. We calculated the administrative cost of our method and rapidity and security. So, calculating cost of our method, we results compared with classic methods, access methods to IoT. It is MAC, DAC, and airbag. And what we can see that adding new users, objects, actions, and context of conditions, our method cost is higher than other methods, but we need to know that our method is dynamic. These 3 methods are static, and they not assessing context of environment. Dynamic changing this parameter. And other 2 tests, we added more users in 100%, and what we see that our method, cost of our method is the same, because the dynamic method, it is context of environment, it is the same. And if we adding more objects in 100%, yes, our method rising in 500 policies. So, the first research, The other research, it is rapidity. Rapidity of our method, it is first test emergency situation. So context of environment we're not assessing, and the replay we are serving about 64,67 milliseconds. If situation is normal with context of environment, without in this situation we don't have any environment context. Yes, we assessing it, but there is no incoming rules. So we have 142. We're looking to it, but there is no policies. And if normal situation with 6 environment context, it is 212, and 12 environment context, 226 milliseconds. So it is more time to replay requests. And security test. In this test, we have 3 objects: home, garage, garden. In these objects, we have different actions. In home, we can turn on alarm or off, switch on the fireplace, garage, rise gate, and so. And these actions can do different persons, depending from this object, action, and person. Our system assessing environment context, calculating baseline riskness, and there we have the ranges to which level this riskness, in which range it can be. Yes. So we calculated different riskness. And concluding this work, we can say that for dynamic assessing, we can use our formula. It is work. The rapidity test evaluation of environment context conditions slow down the decision-making component about 33%. And security evaluation showed that our model is more flexible than other classic methods, MAC, airbag, and so on. Thank you.
Thank you. Do we have questions from on-siters? Of course.
Why not? Well, being a computer person, I would like to ask, you have chosen the linear model for all the formulas. Well, but why not had you an idea to have all these coefficients and the values in powers of 2, so instead of 1 to 3, 1 to 4, and so on?
Maybe idea is good, but what I can say, this proposing this model, it was just first step in our work. We tried with simple formulas, and we wanted to know works of our method or not. So in future work, we can do more complex calculations, and maybe we can try to do some machine learning, but it is future work. And this, I understand, this work was just first step, and it is a little simple.
Simply, you never know how to say, how it should be evaluated. No risk, well, moderate and high risk. So maybe it's even 1, 4, and 8, or 16, or something like that. So yeah, that's
calculations became more complicated, and we need, of course, to try. But I think Raspberry can't calculate this amount of data. Or maybe we need to try this. I can't understand in the situation.
Power of 2, it's just a shift in processor, so that's yeah. So well, and how to say, a particular question. For example, for the gate opening and closing. So, did you calculate or consider situation, meaning out of control, if there's some obstacle you can, or just you block the sensor, and the gate will never close?
No, this situation wasn't evaluated. I think this is more. This is option for the gate rising system, I think. But our system is a level higher on this, so we didn't evaluate this.
If the,
yes, I understand.
So anybody can do anything, and you will not the system will never be able to close.
Yes. It must be some security system, some security option maybe for rising gates, for this system, for motor, for laser, for all these sensors. So we can think about this.
Hello, I have a question about the risk. If I opening the doors from abroad, it will be more risky or not? How will react your system?
Opening the door from abroad, yes, of course, it is more risky than it is opening from inside, because from outside, I can get to the home alone, but maybe I have the bad person with me, and it can access the house. So it is, of course, it is more risky than I opening the door from inside. But if situation is that the door is open, can open the child, and maybe it is in night, so it is very high riskiness, and our system can calculate that riskiness is more than 18, yes, and it blocks this option. The child in night can't open. It can be the situation.
Okay, but for example, I'm not in Lithuania, I'm something else in Spain, for example, and if I want to open, so the system will block it.
Yes, it blocks. If it is higher than 18 level.
Thank you.
Okay, and I have one question. Could you please open this slide where is the controllers and parameters?
Controller?
Yeah, this one.
Yes.
And I wonder, there are 3 units of controllers with 3 different configurations. So you used not, let's say, you used the 3 controllers only with different kind of configuration.
Yes, different controllers. It is type of controllers different, but they are configured for different.
This ID is not the particular controller ID. This is the type ID.
Type ID.
Okay.
Yes, it is type ID, and with different configuration of this controller.
Yeah, it's clear. It's clear. Thank you. More questions? Okay. Thank you.
Thank you.
Congratulations. Yes, and we have next presenter. Next presenter should be Falk Mora. Yeah. Okay. So, yeah, the floor is yours.
So, could you please start? Of course. Hello, everyone. My name is Falk Mora. I'm a scientific researcher at the University of the Bundeswehr Munich in Germany. And today I want to talk about our paper leveraging semantic search and large language models for domain adaptive information retrieval. And together with my colleague Benjamin Stecker, or Fehmeyer nowadays, I've done this work over the past months. And what motivated us to do this kind of research were the companies that we were working with at the time. And all these companies had one thing in common, that they have lots of content to offer, be it products or product information, services and news. And they all required their customers, stakeholders, or just users to grant access to this information. The last thing they had in common were that the systems that they were using on their websites were keyword based, meaning that if a user enters a query, he needs to enter the right words to find the results for his query. Therefore, these systems are keyword dependent, they require a lot of customization, and they don't allow the entering of natural language questions or the generation of natural language answers. Therefore, we had the idea of combining semantic search and conversational large language models into a domain adaptive question answering framework, where we think that this grants us fast and accurate search results, the possibility to enter entire questions as well as generate entire answers. We think this system could adapt to any kind of domain knowledge that you may have, and that you do not need to retrain your model on the knowledge base that you have, because if you extend your knowledge base, you do not want to retrain a large language model, of course. So in our research, we had some questions. First of all, how semantic search can be combined with conversational large language models, how the system affects the search experience for customers, and how the system adapts to new domain knowledge. This, in consequence, brings some benefits and drawbacks with it, as well as challenges, considerations, and design decisions when designing or implementing such a system. So let's come to the concept of our domain adaptive question answering framework. First of all, we need to know that we have two components. The first one being the semantic search pipeline, where we have data, your company data, for example. Then we have an embedding model that transforms the company data into a vector representation, and then you store these vector representations within a vector database for later indexing, for later querying. The second component that interacts with the first one is the conversational question answering system, where we just chose a conversational large language model. So let's dive a little bit deeper into the details of this system. First, by looking at the semantic search pipeline, where we have the indexing stage. First of all, you need to fill up your database with your data. Therefore, you may have some documents, be it Word documents, PDF files, or content from any kind of content management system. And then you start your raw data processing by extracting the content of these files and having Python objects, for example. You then compute your embeddings by sending the contents to the retriever model, which generates some document embeddings. And then in step C, you store these embeddings together with the content itself and the metadata in the vector database. When a user now enters a query, he wants to search for some content within this database. This query is entered, and the same retriever model computes an embedding for this query. This allows us to compare the entered query with all the documents in the database by computing a distance metric, for example, cosine similarity or dot product similarity. And then we sort all these documents in the database and return the most similar documents to the query. We chose a top K of maybe 3 to 5, depending on the model that answers the question. And the most interesting part happens when we add our conversational question answering system to this framework, where we start by first entering a query by the user. This query is sent to the semantic search pipeline, all the steps that I've just talked about. And the semantic search pipeline returns some documents. And then we start in step Roman 2, initial prompt creation, by creating a prompt out of the question and the retrieved documents that is sent to our conversational large language model. This in turn then generates a response which is displayed to the user, and if the user is now not satisfied with the result, he can enter a follow-up question. Therefore, he can ask a little bit more about the details, or if he did not understand something correctly, he enters a question. This question is as well entered into a prompt which is sent to the model, and then we get another response which is displayed to the user, and this can happen in a loop until the user is satisfied. So let's look at our implementation. First of all, as already mentioned, we have used company data, a company that offers specialized technical products. We have used the user manuals for these products, about 130 PDF files, And then we were starting by pre-processing these documents. We cleansed blank lines and removed multiple white spaces. We split each document into 6 passages per document, and we did not use a sliding window. So all in all, we mainly took the content as is. And then we started developing a prototype for this system. First, by choosing a conversational large language model. In this case, we took GPT 3.5 because of the simplicity of the usage and obviously the strong performance. The retriever model was also an OpenAI model. We took Elasticsearch as a vector database, Haystack as an open source library for semantic search, and Streamlit as an open source library for a simple web application. Lastly, we have done a simple evaluation to prove our concept, and this is what I want to talk about now. Our concept had 50 domain-specific questions for all the PDF files that we have gathered, where we created conversations by entering the questions into the system, and we entered follow-up questions if it was necessary to gain the most precise answer of the system. And then we stored these conversations and had 3 independent annotators rate these conversations into 3 categories. First, if the answer is correct, if the answer is incomplete, or if there is no answer at all. They also had the ability to enter comments on the system behavior, especially when the system was faulty. The user could enter what the reason was for the incomplete or wrong results. So our results are displayed here. We have 83% of correct answers, 4% of incomplete answers, and 13% of wrong or no answers at all, which mainly is a very good result, but only for the questions where the semantic search pipeline delivered the necessary content. And in cases where the content was not sufficient, the answer was insufficient as well, which resulted in a problem with the document retrieval because of our data quality. Therefore, we had identified some limitations and considerations when designing or implementing such a system. First of all, the data processing, where we need to think about the way of splitting all the Word or PDF files, whether to choose a sliding window or not, and how to configure this approach. Then data quality, we had a lot of images and tables in our data, which could not be processed by our conversational models. Then we had references which could not be resolved, and it should be thought about if content optimization should be manually done before entering content into such a system. Another thing that limits our work is the database querying stage, where a user enters a query once and has only a single database querying per conversation. Therefore, if you have a whole nother question about a different topic, you just need to start a new conversation, and the system cannot adapt to this right now. And the last consideration is the conversational question and answering model. In this case, we took GPT 3.5, which is limited in tokens, and therefore we had to set the top K documents to maybe 3 or 5, and we could not just pass 100 documents with all the content. The last thing is the prompt design, which might be necessary to get the last bit of precision of the model. So in future work, as already mentioned, we would like to reformulate entered queries so that you just can enter new queries and it gets sent to the semantic search pipeline. We want to discover best practices in data generation and data processing, and we want to evaluate the system for other domains, further models, and with more complex questions. So to conclude, we have defined a powerful system for domain adaptive question answering, which performance is subject to certain limitations, such as data quality, data processing, and retrieval configuration, as well as the integration settings that you integrate your system in. We have integrated the latest NLP technologies, and we think that this system has the ability to improve existing search solutions, especially when you combine it with the existing ones, so that a user can still enter product numbers and just get the product displayed, as well as entire questions, so that he or she can get answers to complex questions. So that's it for my presentation. Thank you so much for your attention. Are there any questions?
Thank you for presentations. Do we have right questions? Okay.
Thank you very much for your presentation. As far as I know, you did this work a month ago, or a while ago. And since then, the whole area developed. We have GPT-4, for example, right now, and open source models. As far as I understood, it's quite easy for you to replace the embedding model, for example, or the generation model. So you just could replace GPT 3.5 with.
These models were just chosen because of their simplicity of usage. We had an API that was just necessary to call, but you could also use GPT-4 or the next version if there's one to come. But you can still use models that you deploy on your own hardware, like Llama models, for example. If you want to fine-tune them for your specific language, for example. So all the modules in the system are replaceable and customizable to your own needs.
And from a user experience view, isn't it too slow when you are interacting with this kind of search?
The semantic search is extremely fast, like in the millisecond area, which a user does not even recognize. The generation process, yeah, this could take longer depending on the hardware and the traffic on the API, for example. And I don't know if everyone has used the OpenAI API, but sometimes there's so much traffic that it gets slow. But if you want to ensure that it's fast for your users, you may use a single model on your own hardware and just.
Thank you. More questions? Okay, no more questions. Thank you very much. Okay, so next presenter. Do we have an online presenter for the presentation number 3? No. Okay, but we have the presenter for presentation number 4, yeah? Okay. So Vera, can you hear us? Hi Vera, can you hear us?
Hello, I'm here.
Okay, glad to see you. So okay, the floor is yours. You can start to share presentation.
Yes. I share my presentation. Can I start? Do you hear me?
Yes, we can hear you.
Okay. Hello, everyone. I'm Vera Schendrik, researcher at Malmö University and head of the Information Technology Department at Summa State University. I present a result of the work carried out with my colleagues at Malmö University in Sweden and Summa State University in Ukraine. Implementation hybrid energy system technologies is expected to change the sustainability of power supply by reducing energy intensity and consumption, thereby mitigating their environmental impact. The planning and the management of the system structure and energy have a crucial social and technological implications for power supply. And the smart system resilience and social and technical challenges is vital to achieve the sustainability development goals. A hybrid energy system is a system that combines multiple energy sources and technologies to provide energy for electricity, heating, and cooling purposes. Hybrid energy systems are intricate and varied and use various renewable energy sources simultaneously. Its note was to use relevant information supporting decision making to ensure that hybrid energy system implementing can contribute to increased efficiency, reliability, economic variability, and enhance sustainability. Effective decision-making processes in hybrid energy systems are critical for efficient operation. These processes involve managing system complexity, balancing the device energy sources, and addressing supply and demand uncertainties. By considering multiple stakeholders and making trade-off between energy sources, the decision-making aims to achieve the optimal functionality of hybrid energy systems. One objective of analyzing the challenges related to the decision-making processes in hybrid energy systems is to better understand the difficulties arising from managing the system's complexity, balancing energy sources, and incorporating data. These challenges encompass data integration, quality analysis, and information flow management. Another objective is to identify areas for improvement, such as enhancing data integration technique, optimization data analysis methods, improving data accuracy and reliability, and streamlining information flow on ensure the efficient and effective operation of hybrid energy systems. However, solving these problems requires understanding the system architecture and processes and at what level they take place. The European Committee of Standardization introduced the Smart System Architecture Models, SGAM, to analyze and visualize energy systems use cases in a technology-neutral manner. The SGAM cube can be used to categorize and visualize the various aspects of layers of a hybrid energy systems architecture. The SGAM cube has 5 layers, and each layer can be further subdivided into different domains. This allows for a comprehensive and systematic view of the hybrid energies architecture. The SGM cube can also be used to visualize the interaction between the different aspects and layers of the hybrid energy system architecture. This can help to identify potential interoperability issues and to develop solutions to these issues. The business layer influences function with the function layer by establishing goals and requirements of the hybrid energy systems. The function layer relies on the information layer to collect, process, monitor, and manage data related to the operation of the hybrid energy systems. The information layer relies on the communication layer to facilitate the exchange of data and information between different components and systems within the hybrid energy system. The component layers comprise the physical device to components that comprise the hybrid energy systems such as renewable energy sources, energy storage systems, sensors, and controllers. In this slide, we focus on the information level task. The business layers defines the business models which require information system to support their operation. Provided by the information layer, information system collect and process data related to the operation of the hybrid energy system, such as energy demand, supply, and quality, which are then used by the business layer for analyze and making information decision. Several tasks can be considered at the information layer level at the same time. For instance, this layer can support the development of smart city applications, promote the integration of the hybrid energy system into urban infrastructure, and enable the monitoring and management of energy consumption, and support the integration of renewable energy sources into the hybrid energy system. Therefore, there is a problem as how to integrate data for different purposes. Information support for the management processes of various aspects of the hybrid energy systems takes place at the informational level. There are many different tasks that can be solved to support the work of the hybrid energy system, like data collection and sensing, data processing and analysis, energy forecasting, energy management and optimization, domain response and load shifting, communication and control, failed detection and diagnostic, security and privacy visualization, and user interface. The solution of task is at the information level involves different domains and zones to visualize the complex relationships between the different tasks and domains involved in the SGAM's model information level. Here is present this figure. In this figure, we divided the main tasks that need to be solved and who will influence the information support process. The solution of this task should take place according to the appropriate models. For example, task energy forecasting. The customer's premises domain provides data on the expected energy consumption of customers. This data is used to forecast the total demand of energy in the system. The distributed energy resources domain provides data on the output of distributed energy resources. This data is used to forecast the amount of energy that will be generated by these resources. This task and others can be solved by several different models which can share data between each others. Also integrate data for weather station with data from energy consumption model can help to improve the accuracy of forecasting for demand-side management problems. Integration data from smart meters with data from energy production models can help to improve the accuracy of forecasting for renewable energy sources. We use a huge amount of different data sources, be a problem of appropriate data integration. Thus, we need to build an appropriate data flow model to ensure that the data is collected, processed, and stored in a way that is efficient and scalable. This figure presents the interaction of models and the data flows between them, which cover part of the task of the information level. Thus, we divided the models into the planning level of the power system structure and management, and between them in the data level. The data level includes models for processing the data, such as data clearing and feature extraction. At this stage of work, we are more focused on the implementation of management level models in a hybrid cloud age environment. And operation data that used to work with in real time, which received data from solar panels, accumulators, wind turbine, and heat pumps. And external sources of information include data obtained from the external sources, such as weather data from APIs and the consumption and the generation data from sensors. Data responsibility contains historical data for all models, deployment and storage of data models at each of levels, planning and management, taking into account the EU General Data Protection Regulation and expert information of the evolution of socio-economic scenarios, as well as on the rules of power system management and users for whom it is necessary to display analyzed predictive information and the recommendations is in covering and understanding form. This data that will be need to further optimization of power system and forecast data of energy consumption. The main issues we are working with is how to make energy consumption prediction without storing and transmission actual user data to provide privacy to users. The obvious way of using edge computing. The main idea make a heat demand prediction on a model for mobile phone, and then use this and make further optimization data on the cloud. The main conclusion is maybe like this. Research found that data integration is essential for ensuring the quality of heat demand forecast. The data flow diagram present here provides a clear visualization of how data moves through the various processes and entities within the hybrid energy system. This structured representation of data flow helps to identify the dependency, interactions, and the direction of data flow, facilitating a comprehensive understanding of the system's function and supporting decision-making processes. Our further research concentrate on further focus on addressing the identified challenges such as data quality, data volume, data variety, data speed, data heterogeneity, data incompleteness, data security, and data integration. Further research should also develop an architectural cloud edge solutions based on the data flow diagram processing. Thank you for your attention. I'm waiting for your questions.
Thank you. Do we have any questions from on-site users? No, we do not have questions. So thank you very much. Thank you very much. And now I see that we have the authors of presentation number 3. Okay, Lakshita, can you hear me?
Hello, hi, I can hear you.
Okay, great. So you can share your screen and the floor is yours.
Okay.
I'm just sharing my screen. Let me know when it's visible.
It's visible.
All right.
Yeah, we can see.
So hello, good evening, everybody. Myself, Lakshita Singh, and my research partner, Lakshay Kamra. We are from Delhi, India. So first of all, I would like to thank the selection and organizing committee for giving us this opportunity to showcase our research. I'm very delighted to share with you all my knowledge. We did a research on sepsis, basically synergizing reinforcement learning for cognitive medical decision making in sepsis. So let's start with what is sepsis? Sepsis is your body's extreme reaction to an infection. When you have an infection, your immune system works to try to fight it. But sometimes your immune system stops fighting the infection and starts damaging your normal tissues and organs, leading to widespread inflammation throughout your body. At the same time, an abnormal chain of reaction in your clotting system can cause blood clots to form in your blood vessels. This reduces blood flows to the different organs of your body and can cause significant damage or even failure. The quicker a person receive a treatment, the better the outcome will be. So, healthcare providers used to organize sepsis in basically three stages. So, there is the most severe stage, which is severe sepsis, and then there is septic shock, and then there is sepsis. So, to identify sepsis, this condition or this scale, there have been many techniques which have been used. There have been like blood test you can take, or maybe you can go to MRI and CT scan. So there are many tests which helps in identifying sepsis. And we later we also have used the data set which involves the blood test reports. So this scale ranges from infection and bacteria to sepsis to septic shock. So basically, the test and the report signify so what in which stage of sepsis that person is. Sepsis can affect anyone, but there are a few people which are more prone to sepsis than any other. So the people includes the people who are above 65 and who are newborn or pregnant people, and people who have diabetic condition, because from the test report and the data we observed, there are so many people who has a history of diabetes, obesity or cancer, and people with weak immune system, and also people who have been hospitalized for long for some medical reason, and people with severe injuries such as large burns or wounds. So let's go to the next slide and talk more about the symptoms and causes. So there are many symptoms, and the symptoms includes very basic systems as well, like fast heart rate, low blood pressure, fever or hypothermia, shaking and chills, uh, or the urinary tract infection, confusion, etc. But what causes sepsis is, like I told you as I told you from the first slide, and diagnosis includes blood tests and blood oxygen levels, which we will talk later about in the data set. So how do you treat sepsis? So if you are in the first stage of sepsis, you can actually treat it immediately. So you can you can take some antibiotics, and there are also IV fluids available and vasopressor medications. So as we go to the existing research, there have been already so much of research which has been done. So many of the research uses two popular scores, which is Muse score and New score. So what is actually Muse and New score? So Muse score is basically the data obtained from the already available data of the oxygen level and the blood data. So it uses SAIRS algorithm, which is basically systematic inflammatory response syndrome. And this algorithm is basically a risk assessment tool which designed to identify patients who may be at the risk of sepsis. So this algorithm uses both structured and unstructured data from patients' consultation to make prediction. And the algorithm is basically designed to operate on a patient-to-patient basis, with each consultation serving as an analytical unit. So on the other hand, there has been so much research which is done on the reinforcement learning in medicine. Um, so in the existing research, there have been sophisticated framework which have been used, like Markov decision process, which constitutes a 5 tuple which serves as a foundation for its operation. And different application in the field of medicine have used reinforcement learning. Uh, so there have been also one method which have been used, which was Gaussian process adapters. So it is demonstrated that maximize a time series end-to-end imputation using the gradients of a subsequent classifiers, which actually outperforms individually improving the classifiers and the Gaussian processes. So basically, this technique is also known as GP adapters. Uh, is not just imputed or the missing data. It has recently been shown in the suitable frameworks for handling so many unevenly spaced time series in early sepsis detection. Uh, so moving on to the data set.
Okay, moving on from the for the data set and processing. So for this research, we are using the Mimic 3 dataset, and that is basically the multi-parameter intelligent monitoring and intensive care dataset. So yeah, this dataset consists of randomly selected around 100 people, and it consists of more than 26 tables. This data is basically it is taken every 4 hours and at a time where several data points are present. It yields a feature vector of dimension 48 cross 1 at a given time instance t. And at this instance time, at this instance of time, the state is called as st. The data provided by Mimic 3 is focused on patients with sepsis 3 symptoms that we are using specifically. Since we must apply multiple queries on the data set, so we have to generally filter out our data. So we are using PostgreSQL to filtering out our data set and building all the required tables and relations. These relations and tables are then again filtered to make the final CSV file that is called the mimic table. This mimic table is then directly used in our research, and it facilitates the all the important fields that we are using in our research. Moving on with the software and hardware requirements too. So here we are using basically we are using a Windows laptop with a 16 GB RAM and Ryzen 7 CPU. And all we need is some of the Python libraries like matplotlib, NumPy, pandas, etc. And for the software, we are using scikit-learn and PostgreSQL. So moving on to the triple DQN technique that we are using in this research. So let me give you a brief about the triple DQN technique here. So as the full form suggests, it's a dwelling double deep Q learning neural network. The value of QSA is a function that is computed as the sum of the value being the state at a VS. So basically, triple DQN minimizes the error between target and output. We use neural approximations of Q star SA, which yields optimal value function. In double DQN, this error difference is very large. So to minimize the expected loss between the Q target and the Q output, we introduce a stochastic batch gradient descent in our model. However, by decoupling the estimation intuitively, our double DQN can learn which state are we on and which is valuable to calculate each VS. And yeah, so moving on, our method contains 3 steps, that is action space, reward function, and the model that we used. So I just explained the model that is triple DQN, and I will go on with the action space and the reward function. We will work with a discrete action space for the research. The action space defined is a 5x5 matrix, which will allow cover maximum vasopressor doses and intravenous fluid dosages. So basically, we need these two dosages, that is vasopressor dose and intravenous IV fluids. So these all dosages should be non-zero, and the integer value will be concatenated as a dosage. All the zero dosage entries will be represented by zero bin, and the medical data and records are very uncertain to find. So moving on to the reward function then. We need a successful working reward function to map each state action pair with a numeric value, which will intrinsically define the value of that state, which will finally help our model to reach conclusions. And not just predictions. We basically measure the lactate levels, defining the cell hypoxia and SOFA scores, which gives a numeric value to measure organ failure in sepsis patients to define the overall health of sepsis 3. So these two measures are the key features of a reward function, which will increase in SOFA score, and lactate levels will result in a negative reward. For a terminating patient at the time of the ending state, the state is rewarded positive if he survives, otherwise it is rewarded as negative. This is majorly about the research methodology that we are using for this research. And now moving on to the result and conclusion. So we are concluding this, that off-policy evaluation results indicate that probability of surviving sepsis is high when the return is high and positive, while comparing to the highest valued clinician policy, triple DQN, gives a more stable and accurate predictions for IV, BP dosages, timings, and mortality risk. It was discovered that resulting continuous state space model generated interpretability regulations that might enhance sepsis treatment. Although the focus of this work was on early sepsis identification, it would be simple to adapt the techniques to other clinical advantages such as cardiac arrests, code blue occurrences, ICU admissions, and cardiogenic shock. This will also enable the practitioner to employ the techniques in a real-world clinical context. So yeah, basically this is from the result.
Thank you so much. We are open for questions.
Okay, thank you. So do we have any questions for our colleagues? No. No, we do not have any questions. It's very clear. And thank you very much. Thank you very much. And okay, bye. See you. And now we will have our last presentation. And I would like to ask our presenter Ilona Veitaitė to start the presentation.
Hello everyone. Today I will present our article Modeling Normative Financial Processes with Process Mining. So together with my colleagues, Professor Audrius Lopat and Professor Saulius Gudas, we have participated in the research project Enterprise Financial Performance Data Analysis Tools Platform. It was done during the period of 2020 and 2022 years. So basically, despite the fact that project is finished already, we're still continuing working with this field because it was quite interesting experience and the topic very interested us. So we are continuing working on that, and today we will present some results which was done after the project. So shortly, the outline of the presentation, so short introduction, related works, types of financial processes which is necessary to be defined to see why we did the experiment as it was. Then I will present multidimensional financial space for process mining project specification, which is again necessary for our experiment. Then the process mining application example, which was done with the help of expenditure cycle, and then conclusions. So firstly, the main idea was to analyze the financial data in the project, and we continue to doing that. So talking about financial processes, there are the actions organizations take when they are handling activity, including accounting, bookkeeping, budgeting, etc., etc. And these financial processes are very complex and are divided into several types according to the content or business activities. The financial processes which are done are usually related with the transaction, which is done between the two elements. And to define these transactions, there is a need to use additional documents, additional financial reports, and we decided to analyze it in more details and to adapt normative rules of the financial transactions data recording, and this process can be quite complex and difficult. So we tried to systemize the data into the tables, and let's see what happened. But shortly about the article itself. So the main idea of the article is to show the possibilities of process mining technology to discover a typical model of the normative financial processes. And we chose the example of the expenditure cycle. So talking about the event log as a source of information, it is a kind of a process mining project. And again, it has the data related to finances and some additional data which helps us to define additional elements of the document. And this additional element is timestamp, which in our example was used not as the main source, but just as additional element. So talking about the a list of normative rules of the financial transaction, we did the list of meta events, which was basically divided into financial transaction entities like journal types, document types, account names, which helped us to use this information. So result of the process mining using the normative meta event log is a kind of meta model. So we practically discovered some kind of the pattern of the financial types. So this pattern can be convenient to use and to analyze with the help of the expert the data, the financial data, which helps us to define the reveal its features and to do further analysis. So talking about related work, so worth to mention that process mining as a process is specifically focused on analyzing historical data of process implementation, and the form of this data is usually event logs. So with the help of event logs, we can get information which is provided by the organization regarding its financial data. And this kind of analysis of event logs with the help of process mining technology helps us to do several things. At first, to reveal the flow of the financial activities and their characteristics, to evaluate the validity of financial processes in the organization, to evaluate an organization's performance, and to reveal possible fraud in accounting records. It means that we can do a lot of things, but again, for that, we need to do a lot of additional research. So part of this is defined like future goals, and part of information I mentioned regarding the discovery of the pattern we did, and I will explain it with the help of the example. And I mentioned that before the starting explanation of the example, we need to get familiar with some types of financial processes, and there is some kind of list of them. So expenditure cycle or purchase to pay process, where we are purchasing and making the payment of the goods. So objective is to mine the events per transaction line and understand the regular flow of the purchase. There are also additional other types of cycles like revenue cycle, financing cycle, conversion cycle, human resource, payroll, purchase to pay process, expenditure cycle from the different side that this purchase to pay process can also be known as procedure to pay or requisite to check. So order to cash and double entry accounting. So these types can be analyzed with process mining technology in very detailed way, but again, we chose the first one, the expenditure cycle, and let's continue a little bit about it. So we are using the process mining technology by the discovery of only one pattern of the typical financial transaction, and our main focus was on the expenditure cycle normative model. So talking about discovery of the common flow of expenditure cycle entity types, basically the main attributes. So we used as a source the source documents, journal names, and account names, with some additional attributes like the timestamp, and basically it was the information from the document, as I mentioned, event log. So the discovered common flows of the financial transactions are considered to be the normative meta models or patterns, and basically we're trying to define one of these using the example of expenditure cycle. Going further, I would like to define multidimensional financial space for process mining project specification. And why I need to do that? Because again, we are continuing our work with this financial data and with the analysis of it. So we are using our previous researches. So at first we need to define the specification of process mining project steps, which basically includes the preparation of initial data, like creating an event log according to the financial data of the organization. Then we need to identify these data record attributes as case ID, then activity ID, and timestamp. About timestamp I will talk a little bit later. And the assignment of some other data which may be necessary, but in more detailed researches. So talking about further specification of the project, so there are a lot of process mining tools and their environments are very different, so it is too complicated for financial specialists to use them directly in formulating data analysis tasks, and we try to make this process a bit easier. So previously in previous conferences our researches we presented a user-friendly approach to process mining technology implementation for financial data analysis using a multidimensional space of financial data. And this financial data space shows us dimensions and the members of these dimensions, which can be covered with data from the general ledgers and main financial document of the company, of course with the help of transformation algorithms. So to illustrate this financial data space, I would like to show the image. So as you can see, we have quite many dimensions, and they are divided according to the types. So we have financial statement category, source documents, journal source subledgers, timing, anomalies, internal external changes, location, and enterprise types. Each dimension can consist of a list of members, and depending on the analysis of and aim of the research, it depends which dimension is more important or on which dimension we are focusing more. Again, working with the expenditure cycle, we focused more on the source documents and the journals. Here is an additional list of the figures, so to see all the elements in the textual mode. And continuing with the process mining application example, so we decided to analyze expenditure cycle. And the main idea at first was to create the expenditure cycle rules, so normal flow rules, where we can see the source document where particular information is mentioned. Then we have the journal name where this information is registered. And we have a list of accounts which are involved in the process defined previously. So having these rules and also creating the expenditure cycle matrix, you will see that in the next slide. So this matrix was developed and it was based according to the previously seen rules and summarized by expert experiences related to the detailed rules. So it is important to emphasize that in the case of the task we were solving, the aim was to discover the normative financial transactions model or pattern by the example of the expenditure cycle. And talking about the matrix, which you will see in the next slide, it defines the possible options for how expenditure transaction data can be presented in source document types and indicates the cases in which data records are stored in various journal or corresponding accounts. So the role of timestamp, I mentioned that I will define this part in more details. So in this meta event log is only symbolic, because in this example, meta event log defines logical event flow, but not the real-time events. So they are helping us just to define logical events, and in this case, data from source document type, in our example, dispatch note, can be recorded into journal like a journal ledger or inventory ledger, and the value of timestamp in this case is the same because it do not have the impact for the data. So matrix which I mentioned previously, so matrix of expenditure cycle, normative events, you can see the list of source documents. Sorry that they are too small, but I try to put all the table to see which is necessary to this experiment. Then we have journal name, we have account name, and timestamp, which I mentioned previously. So according to this matrix, and based on the this matrix, we have also previously mentioned expenditure cycle rules. A normative event log of expenditure transactions was created for the process mining tool, and for that we used Disco tool. And this matrix of the expenditure cycle rules is used to create the normative event log, meta event log, and the characteristics of which are as follows. So in line of this aggregated event log is a record whose attributes are permitted aggregated events, so permitted financial transactions or transaction step, but not a record of the actual data. Then the value of timestamp in the line is only symbolic. I already mentioned that. And also the main idea is that in adjacent lines of summarized event log, the value of a timestamp may differ in the records if permissible sequence of financial transactions is specified, but not in our case. So talking about the experiments with the expenditure event log, as I mentioned, we used process mining tool Disco, and we did two process mining projects with a little bit different goals. So in project one, the aim was to reveal the allowed variants of registering source document types data to journal types. So we need to define journal name. And in second project, the goal was to define the allowed variants of recording the source document types data to journal types linked to the allowed account names. So here we had the pair of results. So journal types was linked to the account names. And in the first project, we had the specification from according the matrix, which I presented previously, and the normative rules. So we had source document with case ID, journal name of activity, and timestamp for additional analysis. So there was discovered different source types, 13 of them, case IDs. So purchase code, approval, you will see in the image, and there are 6 variants found for recording source document to journal types. So we defined several patterns. So here is dependency graph of financial entities journal type of expenditure cycle. You see the general ledger, no general ledger, as we had the source documents which was not inserted in this document, inventory ledger, cash register, and so on. So as a result, I mentioned we had received 13 variants, so list of source documents types of expenditure cycle, so 13 different case IDs. Then we found 6 variants of recording source document types to journal types, and we see the allowed recordings of the dispatch note in case one of them, the one variant we chose to show, and it was recorded into journal types. So the process mining tool gives us also a visualization of discovered knowledge of source document type dispatch note, recording to journal types normative rules as a process model. So we additionally received workflow diagram. And second project, so the specification of this part of second project associates journal type and account names creating a compound, so journal name and account name, which they are linked together. Then we have event log data, which is loaded from the same file as like in the previous project. So here we have this kind of specification, so source document case ID, journal name activity ID, and account name is also related to activity ID and additional elements. So the result of dependency map for activity IT, where we have journal name linked to account name, looks like that. And in more detail, so in this case, we found same 13 types of source document. We had 9 variants of the different normative processes. We received source document type vendor's payment check data recording process, so workflow model, and we received summary of dispatch note, one of the variants registrations. So basically, process mining technology is useful and effective in creating process patterns, and these patterns are different. It needs to be a bit updated and improved, but basically, process mining tool allows to train the inexperienced financiers to see are their conclusions are related with the automatically created with a process mining tool, the result, the pattern, and again, process mining technology discovers new knowledge from a set of expert rules. So with the help of experienced expert, it is much more easier to analyze the results of financial data. So conclusions, and the main part which I would like to say that the process mining technology is used to discover the visual models of the normative financial processes, in our case in the example of expenditure cycle. Also, process mining technology allows us to discover 2 types of visual models, so dependency models and of financial process entities, and workflow models, so we can compare the results. And what's more, it is necessary to emphasize that aim of process mining process was to discover the pattern of the financial transaction or meta model based on meta event log comprising summarized experts knowledge. So we used the expert knowledge and automated the experiment part with the process mining technology. And from the results we obtained, it can be seen that the general ledger and inventory ledger are repeated several times in the activity column in the table. So the expert himself has to summarize it, so it needs to be improved a bit. And such a case shows that the possible improvement of process mining tools applying the process pattern discovery based on the knowledge recorded in the meta event log. And the normative meta model of financial transactions could be further used for the experts of financial field and can be used as a pattern in analyzing validity of financial data records, anomalies in financial transactions, and in more detailed way of analysis. So we would like to believe that it will be possible, and again, it would be nice, and we are planning to do to try the similar experiments with different cycles to see how these results can impact or can be changed or improved the entire process of evaluating of financial data. So thank you. Questions?
Do we have any questions from on-site users? Okay, we have it.
Well, I'm wondering if working with those logs, you found some company or some case when the let's say the workflow was changed, and so did that affect your solution, and how did you cope with the result with this such, how to say, changes? Well, but those changes are quite natural.
Okay, thank you for the question. So basically, talking about the analysis of data, we had the real company's data. We had to process and pre-process them for the analysis. And in the project part, we did a bit different experiments, and they were more practical because we had a certain goal. And talking about this experiment, we defined the pattern. Both experiments showed that patterns can be a bit different variants, but the similarity between different experiments results shows that it is possible to compare them and to make some kind of conclusions. But again, these 2 experiments, and only with expenditure cycles, doesn't mean that it will repeat with different cycles. So we need to work more for that.
Yes, and the artificial intelligence module is under construction right now. Who should help to solve this type of problem and this type of question? More questions? Okay, so thank you very much for last presenter, Ilona. Okay, so here is certification. And I would like to provide some information regarding the proceedings. Yeah, so all the material, all the accepted articles are provided to Springer Publish House already. Yeah, and we're waiting for proceedings, and hopefully you will reset them during 1 month. Yeah, and could you please check your mailbox, especially spam folder, yeah, because you will you will receive the final version of the articles, and you should approve them individually, yeah, because we provided as organizer the final versions of the articles, but you know, you should accept them directly to the publisher. Yeah. Okay. So thank you very much. Thank you very much for participating, and this section I announce that is closed. So thank you very much, and I hope to see all of you tomorrow morning at 10 a.m. and we will listen our colleagues Charles Shi keynote speech. Yeah. So thank you very much for all of you again, and hope to see all of you tomorrow morning at 10 a.m. Thank you. Have a nice evening.